你们 relax，要讲好一点，因为他有那个什么拍的那个。
你应该不要说，应该说讲多烂都可以。
没有关系。
讲的烂我大不了就给你们录下来放公司大群里面去。
大家其实并听不懂我们在讲什么，能听懂我们讲的是英语就不错了。
而且我没有 stage 造型的训练，我觉得我会乱晃，会抖腿，会摇啊摇。
这没关系的。
没关系。
这都没关系吗？
是啊。
个性化。
Do an announcement like that.
这不重要，就是要投入进去讲。
是不是要上去？他们会有人帮。
Hello. Test. Hello, welcome to Taskforce 2. We will soon be starting. Please feel free to use the headsets placed on your seat if you would like to hear the speakers more comfortably. Please use channel 1 for Arabic and channel 2 for English. Thank you.
Good morning, everyone. And I'm Heng from Huawei Cloud, and it's such an honor to be here, to be the Taskforce 2 of transportation. And it's also the first time for me to be in Riyadh. I can really feel the warm welcome and the hot temperature of this wonderful city. And yes, as I know, Riyadh is among the world's fastest growing cities. Before the summit, I spent a few days in the area of Olaya, and I can feel the pressure of traffic, as well as the hot temperature. But I think, of course, traffic is the big issue, not only for Riyadh, but also for every city around the world. Yeah. In China, we also witnessed the faster growing of the number of vehicles on the road, and it has already significantly outgrown the infrastructure and becomes the primary reason for traffic jams. From our historical data, 61% of the cities in China have slow roads during peak hours, and 13 of them have congested roads. So congestion alleviation has become a priority to our local governments. And from our analysis, we think that the pain points of the congestion alleviation include 3 parts. The first is the inadequate data utilization, and the second is the poor system architecture, and the third is the heavy manual workloads. For the data, in some cases, the data itself is not adequate. For example, the data may incline to the motor vehicle, but there is not enough data for pedestrians or non-motor vehicles. And in the other cases, we have a huge number of data, but we don't know how to integrate them. And at this case, such data is not sufficiently utilized. For the system, the traffic control systems at each intersection are not connected as a whole network, so they cannot coordinate with each other. And the intersection systems will work more functionally if they are disconnected to the command center. And for the workloads, we don't have that much of manpower to refine the control optimization for the entire city. And the optimization policies are formulated based on human experience. So these experiences may not be generalized well. So traffic signaling is one of the primary means of traffic management. Without an automatic traffic control system, the fixed timing will be the norm. And in this case, it will cause a huge waste of road resources in the face of changing demand. Here is an example of a city in China. During the morning peak hours, the length of the green light for one direction is increased by 15 seconds each year due to the increasing of the traffic flow at a fixed types manner. And the usage of the reversible lane is fixed to 2 hours, and at core source coverage data, quantitative analysis of congestion causes. And to optimize, we're doing dynamic optimizations by different scenario, time, and locations. So last step is to evaluate. Since every city has its own characteristics of traffic, so we build a comprehensive multi-dimensional traffic metrical system to evaluate our performance. Here is the data flow chart of our traffic goal solutions. We can see that the edge devices of multiple sensing input are deployed at the intersection, and the command center is on our Huawei cloud. We can see the video analysis platform, the intelligent data platform, and analysis platform, optimization platform are all on the cloud, as well as the data synchronization module and the signal inference module. Here, the blue boxes are our core capabilities from Huawei, and we leave the green boxes to our partners. Let's start from the first stage of sensing. So let's take the e-police as an example. So a typical scenario at a four-way intersection, we will deploy 4 kinds of e-police cameras, which are front-facing camera, rear-facing camera, flow detection camera, and high-rise cameras. Our minimum recommendation for achieving a good result is to have a front-facing camera with the flow detection camera. This is an example of our all-weather algorithm for abnormal parking detection, which can be used to detect congestion, traffic accidents, and abnormal parking in real time. We can see, maybe it's a little bit unclear, but we can see from the time steps in the traditional way, it took nearly 14 minutes for our police enforcement to discover the traffic accident. And the whole process will take over 1 hour to finish the process. But within our traffic goal algorithm, the system is triggered less than 5 minutes. So it's a huge improvement in terms of the efficiency. So the next stage is to understand. We have different kinds of input devices, sensing devices, including e-police checkpoints, floating car, radar, magnetic sensor, and inductive coil. But these kinds of data are always in a high dimension and very sparse. They cannot be used directly by our optimization stages and following stages. So at this understanding stages, we converge all the raw inputs to 5 kinds of the traffic metrics, which are region and city metrics, trunk and road metrics, road section metrics, intersection metric, and phase metric. So in this stage, our core capabilities are we build over 100 traffic metrics that can be calculated for multidimensional traffic systems from macro to minimum level to the micro level. And we support automatic evaluation before, during, and after our optimization. And our different traffic metrics can also comply with the different national or global standards specifications, and each record can be traced and reviewed. The third stage is to diagnose. Here we have a spatial temporal congestion diagnosis based on the traffic health metrics and symptoms. Specifically, we built a road health archives, which is built on the intelligent analysis platform on the Huawei cloud. And with the input of real-time data and historic data, and using the congestion analysis algorithm. With the road health archives, we can discover inappropriate time allocation. This is, for example, we are having too short green light time, so the starting time will be occupy the most of the green light portion, and it will be less efficient for the green light time. And we can also discover inappropriate space allocation and time and space allocation. So these two are basically for road level and the region level diagnosis. So we also considering a different traffic governance policy like laws and different laws and rules. We incorporate these kinds of policies into our library, and this can be automatically match our optimizing policies. The fourth stage is to optimize. So this is a pipeline for our optimization systems. So we already have the different kinds of traffic patterns and traffic policies, which we are converged from the previous sections. And these data are fed into our optimizing algorithms. This could be the neural network or other kinds of machine learning algorithms. And we can optimize with different kinds of constraints from our libraries. So in this stage, we can visualize the optimized process. And we can use the modified AI timing, periods, and sub-areas based on different kinds of service. And we issue traffic control policies. Here we're going to give you two examples of our optimization stages. The first one is the signal timing optimization for each intersections. So for each intersection, we have the inputs of traffic flow features, behavior features, traffic flow conflict features, and traffic anomaly features. So these features are automatically generated from previous stages, and we can do adjustable timing based on the traffic flow. We can do the waiting period optimization, do the phase optimization, and to the max min green light time in a phase. So our goal here at each intersection is to achieve zero idle green light with the use of AI algorithms to dynamically adjust the signal timing, and to do the zero intersection overflow. When the lane is occupied over 70%, the green light is lit and allow the vehicles to pass automatically. And we're also considering the pedestrian information and data, and we can optimize the street crossing timing and determine whether to add a pedestrian phase for the traffic side. The next example is traffic organization optimization for space allocation. Here we focus on adjustable lanes and reversible lanes. We discover traffic flow patterns by analyzing historical data and detect the queue length in real time. So we can turn the left lanes can be flexible just to improve the road utilization and efficiency. And we discover the traffic flow by analyzing the historical data and analyzing the driving time changes, traffic changes, peak hour changes in a quantitative manner, so we can change the driving direction of one or more lanes during different periods of time for the reversible lanes. The last step is to evaluate. Here we don't go to details of the table. I just want to give you a picture that we have different kinds of metrics for the evaluation and for the optimization constraints. So each criteria is built for each kind of purpose, and this kind of purpose should be incorporated to the specific position or cities which it will be deployed in. And let's have an example of our evaluation of our own algorithm deployed at the Huawei base in Shenzhen. From the left side, we can see two pictures. The left pictures is the land usage analysis. So Huawei campus in Shenzhen is divided into several zones with clear functions. And the internal zones are office and work zones, and the external blue zones are for living in the commerce. And the centralized office have very heavy traffic during the work days. And the peak duration is very short, and the traffic flow is concentrated during the peak hours. And pedestrians especially are concentrated during the peak hours because the living area is just besides the working area. And so we used like land usage analysis and traffic feature analysis. We calculate our algorithm's performance and get the result of faster average vehicle speed and less driving time. And our traffic goal system is already deployed in the Shenzhen traffic police. Maybe some of you might not heard of Shenzhen. Shenzhen is the third largest city in China in GDP and population, and is the #1 city in terms of vehicle occupancy density. And the traffic before in Shenzhen is not that good. Traffic data collection, traffic optimization, emergency response. So all kinds of these things rely heavily on human labors, and inappropriate signal timing, plus inability to dynamically change the schedules compromise the road efficiencies. So after our deployment of traffic goal systems, we can achieve like the results from 6 intersections near Huawei base. We achieved this over 6% faster average vehicle speed and over 10% short driving timer and 12% shorter delay time. And we also deployed our traffic goal solutions to over 100 intersections in other districts inside of Shenzhen. And it's also included in the top level design of the smart transportation design at another 700 intersections in Shenzhen. So next I will hand over to my colleague, Dr. Gu. He will talk to us about the other two scenarios of the transportation we have done in Huawei. Okay, thank you.
Hello. Yeah. Good morning, everyone. Thank you for joining us in the AI for Transportation Task Force. So my colleague has already give you a brief introduction about the overview of the traffic goal system in Huawei. So in summary, we think that AI in transportation is not just one system or one company. It's about an idea that nowadays we are living in a digital world, which means that data are created, recorded, and used by all the digital systems. So, but we think that data is not equal to knowledge. That when you try to support a decision, knowledge is what you need, but data is not. Data is like the raw things you get from your sensors. But how to turn these data into knowledge and support your decision and your optimization and planning, we need some tool to turn this data into knowledge. And we think AI is that kind of tool. So in this section, I will briefly introduce you two more specific cases in our practice in AI in transportation. So for one specific problem, we will think, what is our goal? And how to achieve that, how do we measure the goal? And how and where do we collect the data? And how do we turn this data into knowledge using AI tools? And how we deploy this system in the real world application. So the first one is about intelligent bus scheduling. So for bus scheduling, we care about two things. The first one is the experience of passengers, right? So let's think about you are waiting for a bus in a bus station. The first thing you want to know is that when will the next bus come to this station, right? So we try to estimate this time of arrival of each bus for every passengers at this station. That suppose you are waiting for one bus, we will show on the screen that what is the estimated time of arrival for that bus. And second thing, aside from the experience of passenger, we want to improve the efficiency of the entire transportation system of this city, right? So, so how to measure that is basically, let's say in the morning peak, how many bus shifts can I send to the entire transportation system? If I can send more buses, we think that you can improve the efficiency, like you have more capacity for the passengers. So these are the two major goals in this bus scheduling project. So the first one is, how do you estimate the time of arrival of a bus? So we first think about to estimate that, what kind of data do we need? So here we collect three kinds of data. The first one is we obviously we have to know the current position of that bus, right? So nowadays we can easily collect that from the GPS data. Like each bus is equipped with a GPS device, so you can know the current position of that bus. So this is the first one. The second one is about the traffic, right? You want to know the traffic condition of the road, and you also want to know one important thing for bus that is different for like other cars is that you have to, like each station you have to receive the passengers. That also takes a lot of time. So you want to know the condition of the passenger flow at each station, right? So in China, I don't know what, like what's your practice in Riyadh, but in China, like when you go on a bus, you will need to use this bus card, and you touch the machine, and it will like deduct some of the bus fees, and it will also record the time and the location where you get on that bus. So we collect that kind of like bus card data from this digital system, and we also use that to estimate the passenger flow. Like at this station, how many passengers get on this bus? So you will know the capacity of this bus, and at the next station, you can estimate like how long do people need to wait for this bus. So this is a passenger flow and traffic data. And the third one is the metadata of each bus line, which means how long this bus line is and what is the distance between each two stations. So given these data, we will train this model. I think you're probably quite familiar with machine learning. So this is basically a very simple regression problem, right? You extract the features from these data you collected, and you feed it to a regression model, whatever it is, and you will output this estimated time of arrival. And at inference time, we will collect the GPS data and the passenger flow data and use the metadata, and we will output the estimated time of arrival. And given this estimated time of arrival, you can help the urban transportation system to really schedule it from a global level, saying that, okay, I know that each bus will take how much time to get to the next station. So given that kind of information, I can schedule it globally to really reduce the overall time of waiting. So how do we evaluate that? That we picked a representative bus line in Shenzhen. As my colleague has introduced, Shenzhen is one of the largest city in China. I think it's like double the population of New York, has like twice as much people in New York. And they say that every issue will get 10 times more complicated in China because we have so many people. So we picked this one, this bus line in Shenzhen. Its total length is around 10 kilometers with 21 stations, which is a representative line in the bus system. So you don't really need to have to look at the numbers in the table. The basic idea is that we train the regression model with around 500,000 samples from 2020 with the data within like 4 months, and we use like 20,000 samples as our test data set. And we want to see that how accurate can we make predictions about time of arrival of each bus. And in this table, each row is basically a pair of starting station and the end station. And you can see that the overall prediction error ranges from 0.6 to 2.1 minutes. So usually we can control the error of the estimated time of arrival within 2 minutes. Like let's say the entire time for the bus line is like 40 minutes, and for each pair of station, we can control the error of estimation to 2 minutes. So for the passengers, I think this is like a slight improvement of their experience, that they can know the accurate time of the next bus. arrival. And for we tested in the morning peak, evening peak, and the flat peak, and the curve actually matches the real data well. So we also think about that whether this model can generalize to other situations, to other scenarios, or it just works in Shenzhen, right? So we take the model trained in Shenzhen and we deploy it to another city in China, the Chongqing city, and we pick this bus line 429 in Chongqing as an example to test the scheduling and the estimation system. And it turns out that the system actually generalized well to another city. Like in Chongqing, all the data also fit the real data as well. Like the average error is low, and at the same time, when you try to optimize the global transportation scheduling system with the data you collect and the time you estimate it, we find that we can, like for morning peak alone, we can increase the number of shifts of bus shifts from 69 to 77. Like you can send 8 more buses to this system to increase the capacity of urban transportation. So this actually increased a little bit. So you can see that the AI for transportation, like it doesn't matter how complicated the model you use. Here we just use a very simple regression model, but it really about like how you define the problem, how you collect the data, and how you train the model to fit the goal you want. The next one is about our practice in smart airport. I believe many of you like take the flight to our yard, and every time I take a flight, I hate waiting in many like different places. Like the flight can delay, right, and you have to spend so much time in security check, and all of those things are annoying. So at the airport, we have the same goal, right? We want to improve the experience of each passenger, and at the same time, we try to improve the efficiency of this airport. Like for an airport, it's actually a more challenging problem compared to the ground transportation system because like you only have very limited space, like very limited airport stands in one airport, but you have to like take so many flights and so many passengers. So this is a challenging problem that to how you plan and optimize your scheduling system for the airport. So as we introduced, Shenzhen is a large city, and for the airport, I can give you some statistics. Like every year, Shenzhen Airport will serve over 50 million passengers, and every day there are around 1,000 flights like go past the Shenzhen Airport. So this is a big problem for us. So which also means that even if you make a small improvement, you will like bring a huge difference because you have so many passengers that can be influenced by your system. So the goal of a smart a smart airport is safety, efficiency, and passenger experience. So for safety, we want to improve collaborative emergency response ability and try to respond in short time. Because if you do everything manually, first of all, it's expensive. Second of all, you cannot respond very quickly because whenever an emergency happens, you probably have 50 or 60 rules to apply. And if you adjust for one airplane, you will influence all of the remaining ones. So it can be really challenging for a manual allocation system to respond to the emergency issues. And second one is we care about efficiency, that, as I said, we try to reduce the aircraft turnaround time and improve airport capacity utilization. And for passenger experience, as we said, we want to reduce the time of waiting for each passenger at like different sessions. So previously, when we manually do this allocation, it can be expensive, inefficient, and ineffective. Like, I won't repeat the things like the shuttle rides will lead to poor experience, especially in bad weather. And manual stand allocation takes up to 4 hours and is error prone. So for this stand allocation, for a stand, we mean that the place where you you do the maintenance, where you stop a plane, and you probably will add some fuel to the plane. So these are the very limited space. So we try to improve the efficiency of this allocation. Right, and yeah, we want to achieve an efficient airport and happy passengers. So So let's consider like 3 scenarios. The first one is sensing. So for sensing, we mean that how you collect data. So as an intelligent system, you have to know what's going on around you, right? You have to know the status of the airport. You want to know the status of the counter. You know the status of the passengers. So we have to like find an automatic and intelligent way to collect data to sense the status of the airport. So we apply the machine learning algorithms specifically in this computer vision one to retrieve important information from the video data we collect from the airport. So at each position at the airport, we will have this camera and we collect data. And for example, now you're seeing here is the video image from the airport stand where they are doing maintenance for this plane. So from this video, you can know which stage are we at for this plane maintenance. So you can estimate like how much time left for this maintenance. So we use this segmentation algorithms and these object detection algorithms in computer vision to extract important information from the videos. So from videos, you can not only know the status of these airplanes, but you can also know the status of passengers. Because at every queue, you also have a cameras, and it will tell you the status of each counter, how many passengers are waiting, and how long is the queue. And the second thing is, once you have already collected the data from these sensors, from these videos, that you try to use those kind of data to do more intelligent resource allocation, especially for the scenario for stand allocation, right? So now with the Huawei AI system, it only takes 1 minute to allocate stands for over 1,000 flights in a unified manner. And as we said before, the allocation is a complicated system. Like you have so many rules to apply, and once one flight changes its schedule, you have to change the ones for all the remaining ones. So once you have an automated and intelligent system for that, everything becomes like much more simple for like compared with the traditional manual scheduling system. And also, this automated system is 24/7. Provides 24/7 service, and whenever it comes with an emergency that you have to change some of the schedule, it will automatically change the rest of you. So it's a huge efficiency improvement compared with manual allocation. The third scenario is about the queue management for the passengers. That, as we said before, at each queue, at each counter, we will have a video to record the status of each counter and the queue, like how long it is, how many people are waiting there. So once we collect those data, we can give it, we can extract this kind of information from real-time video, and we send it to an intelligence system. We will give it to an AI-based solver to tell you how to allocate this counter, like where should you lead the passengers to, which counter. So it will improve the overall efficiency, the global efficiency of the airport, and will reduce the time of waiting for the passengers to improve their experience. And for some, for these scenarios, we also have some numbers that how well are we doing in this thing. So the first one is how accurate can we do for this data collection, for this information extraction, to extract information from the video. So we find that we can actually do this information extraction with accuracy more over 90%, which means that for most cases we are extracting very accurate data. And once we extract the data, we can also visualize it in a platform that the schedulers or the workers at the airport can really see the real-time status of the passengers, and we can plot these curves based on the information we extract from the videos. So compared to manual allocation, we can improve the hourly check to a real-time check that traditionally probably every hour you have to send this one stuff to each counter to see like how many passengers are there waiting, but now we can do it in real time, and we will reduce the time for passengers to wait in the airport. And for stand allocation, we actually can. So once we deploy the AI system, we actually increase the number of flights every day at Shenzhen Airport. And as I said, there are so many passengers served by this airport. So even this very slight improvement can lead to very huge difference. Like nowadays, we can we can reduce the number of passengers that take the shuttle bus by like 2.6 million passengers. That these passengers traditionally they have to take a shuttle bus to the airport, but now they can directly get to the airport by the bridge because we have like more intelligent scheduling system. So so in a big problem like transportation, every slight improvement can bring a huge difference. Okay, so now we can take a look at a video about the introduction of the smart airport in Shenzhen. We're providing a very friendly and easy-to-use platform for the schedulers. Once you have a conflict, you can quickly respond to that. And this is the allocation system, as I mentioned. Can automatically recommend you the scheduling for the airport. So that's pretty much about our introduction about air transportation in Huawei. So you have our information in the summit schedule. So if once you have any questions, please feel free to shoot us an email so we can have more discussion. Thank you all very much.
Hello, welcome to Taskforce 2. We will soon be starting. Please feel free to use the headsets placed on your seats. If you would like to hear the speakers more comfortably, please use channel 1 for Arabic and channel 2 for English. Many thanks.
So, good morning, everyone. Focusing quite a bit on the Middle East. We are, in fact, spending a lot of time doing decarbonization projects, building on a lot of analytics in the region. Can I ask you to introduce yourself, Dr. Alawi?
Yes, my name is Abdelhamid Al-Alawi, CIO for Digital Transformation and IT in Ministry of Environment, Water and Agriculture. I'm glad to be here with you. Thank you, Shelley, for this nice introduction. I'm very happy to be with you all at the Global Summit that is held here in Saudi Arabia under patronage of Crown Prince. And I'm really happy also talking with the expertise from Sadaya, from Google Cloud and the Climate Engine. And this is very opportunity to talk about the challenges of our sectors. And thank you so much for this introduction.
Thank you. And we have Mr. Franco.
Good morning, everyone. My name is Franco Amalfi. I'm head of sustainability strategy for Google Cloud for public sector. I'm very excited to be here to launch this partnership with Sadaya and the Climate Engine. We're really focused on bringing technology to help with climate adaptation. Thank you, everyone, for coming.
Thank you. And we have Mr. Abdurrahim.
Yes, thank you, Shelley. And good morning, everyone. Assalamu alaikum wa rahmatullahi wa barakatuh. أنا مسؤول عن جوجل كلاود في المملكة العربية السعودية للقطاع الحكومي. I'm the head of the public sector Google Cloud in Saudi Arabia. I have joined the company little more than a year ago. Before that, I had the opportunity to work in a few organizations that are related to Vision 2030. So I understood the importance of the vision, and I have seen the execution, and I have seen the important focus on sustainability and on the environment. And I am very lucky to be in this position because I realized that this is a great opportunity to support organizations like the Ministry of Environment, Water and Agriculture, and also Sadaya in achieving kind of innovation and innovative solutions to implement here in Saudi Arabia.
And Mr. Caleb White.
Thank you, Shelley. My name is Caleb White. I'm the Chief Operating Officer of a company called Climate Engine. We're a very close Google Cloud partner and been working with Sadaya on an exciting project over the last several weeks. So thank you, Sadaya, for the invitation to come over and visit Saudi Arabia. I'm from Ottawa, Canada, and our company focuses on delivering climate insights as well as sustainability. And so really looking forward to speaking to you all today.
Very good. So what we will do in the next hour is that we will have a series of presentations from each of the panelists, including myself, and then we really would like this to be an interactive session. We open up, once you understand what each of our panelists is doing, to any questions that you might have on how we would apply this within AI today. So maybe, just to get started here overall, I go to the, yes. We start with the MIWA slides. This is fine. Yeah, go ahead. Yes.
Welcome, everybody, again. As you know, Ministry of Environment, Water and Agriculture is responsible for three crucial sectors. The first sector is the environment, water, and agriculture. And based on that, we have developed three national strategies that have been approved recently. We have the National Water Strategy, the National Agriculture Strategy, along with the Environmental National Strategy. Also, we have developed the digital transformation strategies that are aligned with these strategies. In addition to that, these all strategies are in line with the KSU Vision 2030. Also, as you have heard about Saudi Green Initiative and the Middle East Green Initiatives, these initiatives are a very challenging project, And we today will talk about some key enablers from our project with Google Cloud and the climate change, and to talk about our product that we are initiating the first stage of it, the as you know, the intelligent planet. As you have known, this is our strategy, maybe the highlights of that strategies, our visions, our as you know, we have many challenges in the different sectors, the three sectors. I'll take example of each sector. If you go to the environment, we have climate change, one of the challenges, and how to increase the vegetarian coverage or the green coverage, how to reduce the implanting. The other challenge that we face, as you know, in the agriculture side, we have the food security, the food supply chain, how to save the national productions of crops and greens, etc. Not only that, if we go to also water, we have a lot of challenges that we need to have some smart solutions that save us a lot of resources to go with. Like, as you know, we have limited resources in water. For this, having said that, we have what's so-called sustainable development goals, starting with our rule, the ministry rule in achieving sustainable development goals. And that one, as I said, it comes in line with the digital transformation strategies. And as we know, we have our Vice Minister today launched the first center with Google Cloud, Sadaya, and the Climate Engine today. And it will be, we will work this year on the first stage of this portal. And we'll talk about it. This is the AI Center for Environment, Water, and Agriculture that just launched 1 hour ago. It is a strategic partner between our ministry and Climate Engine, Google Cloud. They will take all the aspects of technical infrastructure, and we will have some global expertise in artificial intelligence in the different fields. Also with the advisory with Sadaya. Sadaya is playing a major role, really. We would like to thank all of our partners on the expediting the process until we have reached to this. We have some many use cases on our plan. I will take some example because the first use case is the climate change for the environment. We will have this platform as a key enabler to also to reduce the emission of the environment. For water, yes, we need to save the water ground levels. We try to save the consumption, the huge consumptions of the water. As you know, we are environment, water, and agriculture, and these, you cannot have the first two without the third one. So we need to be very careful with this. Also, as I have said, the food security is very crucial on this. Thank you again, and I think this is my time to talk, and thank you, Sheikh.
Thank you very much. And congratulations on the launch. So I think it's fantastic to hear what's happening with the ministry overall, but we wanted to take a moment now before we move forward just to set the context a little bit for these phenomenal changes that we're seeing here within the kingdom, but then also to recap on the case for change overall. What we're seeing here globally at the moment is that we have committed to the 1.5 degree pathway. And I think there is one number that I would like you to remember, which is the 50 gigatons with a 50% reduction. The reality is what we can do together by bringing together these functions of AI and climate and sustainability is expedite our movement along that path. Where we are today, with the current policies, we are heading to a 3 to 4 degree rise. with the pledges and targets that we have, we will be above 2 degrees. So the reality is that we have an existential crisis that we are dealing with at the moment. What's interesting for us is to solve this solution, we need to activate across all sectors. Yes, power, industry, transport are relevant, but there's a lot that has to be done in the agriculture sector with buildings and a number of other spaces. Here we talk about emissions, but the reality is that when it comes to adaptation and resilience, which is a lot of what you're looking at, and a lot of the data that we can be using, we are going to be able to activate across all sectors by bringing together the data, science, climate, and the environment, and the functions that we have. The key element for us is that data is becoming increasingly accessible. A lot of you here today, and especially Google and its associates, has a phenomenal amount of data on hand. This data is coming from governments, health data, satellite data, it's coming from corporate data, and it's coming from very unstructured sources, from the activities that we have on Google, Facebook, and Instagram. So with all of this data now, there's a lot of new information that is becoming available. Why am I saying this? Because it allows us to skip a lot of the experiments, the surveys, the research that we had done in the past to move more quickly and to achieve our goals much more quickly than we had. These data science capabilities, the fundamental of what we're bringing to the table today is the predictive modeling. The ability to use the algorithms that we have in place to predict future events. In addition to the predictive modeling, we have descriptive modeling to help us understand cause and effect. Optimization, which is a big one for us, especially within industry and transportation, to understand how we can use our resources more efficiently. Natural language processing, which is not only which we are applying today in industrial sectors, and overall simulations. So these capabilities are really unlocking for us a lot of new solutions in environmental and social impact overall. One of the things that we have looked at is where do we expect AI to have change or significant change? And we looked at what's the impact going to be across sectors on the offering that you bring to clients, so the products. What's the impact that AI going to have on your internal processes? And what we have found is that there are some industries that are going to be more disrupted than others. Sectors like IT and technology are obvious, but then we also have logistics, transportation, biopharma, biotech. So whilst we have representation, we'll talk a lot about certain sectors today, I think it is important to consider that the impact that we're having from AI on the environment is going to be across all sectors. The most pressing climate changes that we expect to impact from AI are going to come from the management of impacted systems, which I think you're going to be looking a lot at. Adaptive action, so how do we respond to these systems as they're changing, and then how do we manage the emissions issue overall. And just to spotlight one or two, I think, use cases or issues that are relevant, we look overall at agriculture and food security, which is quite relevant within the region, but is in fact relevant for a large number of countries globally. And some of what AI can help us do is to look at yield prediction, soil carbon sequestration, and a lot of these applications are in place. What we see as BCG, which I think is quite powerful, is that not only are we working with the public entities, but a lot of our groundbreaking work is also being done with large players like, I would say, Diageo and other players globally, where they are looking to manage the entire value chain and to work with the agricultural systems overall. So many solutions, I'm not going to go into them, but I think we take into consideration different categories. So yield protection, environmental disasters, carbon sequestration, and earth radiant imbalance are some of the four where we are seeing most traction today. And I think where there are strong models that are being used to create value within the different ecosystem. And I want to end this little introduction to say, we will speak a lot about the data, we will speak a lot about climate and sustainability, But what we have found time and time after again is that the corporates that we are working with are using the data, using the impact that they want to have on the environment to create more value through new products and through increased margins. So it's good for the environment, but it's also good for business overall. And I think that's what's very exciting about the panel that we have today. So now I would like to invite you, Franco, maybe to talk a little bit about what you're doing.
Yes, thank you. So good morning again, Franco. Today I will talk to you about how sustainability is really important to Google. We are investing heavily in building capabilities for helping not only ourselves. Google is investing a lot of energy and a lot of money to make sure that our operations in our data centers, we are carbon neutral. We've been carbon neutral since 2017. We have billions of users that use our technology every day. So when you're using Google technology, you know that you are carbon neutral. We also made commitments to be carbon free by 2030. We're also making significant investments in our products, our services, to reduce the amount of energy we use and also to use recycled materials. But we're not stopping there. There's only so much we can do as a company. We also need to involve others. We need to involve government from a policy perspective. We need to involve our customers to help them better make decisions and use technology to be able to reduce their carbon footprint. And last but not least is helping consumers. There's 2 billion people every day that rely on Google technology through search, maps, and other capabilities that we give them choice. If you go Google for a flight, we tell you which one has the least carbon footprint. If you if you're using Google Maps and you're going from point A to point B, we're going to show you an eco-friendly route, and it's already removed the equivalent of 500,000 cars in the US alone last year. And we're now rolling this out in Europe and in the rest of the world as well. We're also showing bike path and bike capabilities, and we are also putting hotels and information. So we're surfacing more and more sustainability capabilities in Google Search. So as you're making choices, you make better choices. So combined, we can actually help reduce our carbon footprint. Shelley talked about a magic number, 1.5 degrees. We are nowhere near there, and we only have 100 months to get there before the year 2030, where we all make commitments, so we have to work together to get there. Specific to public sector, sorry for that, we actually are very, very focused on the same things that all of you are thinking about. So we're really on our cleanest cloud. We run a carbon neutral cloud. We have the most efficient use of the cloud capabilities. We use what's called power usage effectiveness. It's as close to one as better the most of any hyperscaler. That means we actually almost all of our energy is used for computing power. So we actually reduce all of our capabilities. We use wind energy, we use solar energy, geothermal, and we increasingly add more and more renewable energy sources into our data centers. Also, carbon-free commitment by 2030. We're investing heavily in making that happen. As you can imagine, that is a very big challenge, and we're up for it. We are spending a lot of time making sure that we get there. And last but not least, we want to provide climate insights. And that's really the title of the session today. And that's my work. That's what I do, working with partners like Climate Engine, BCG, and others, where we bring technology to give information and insights to organizations, both in the private sector and the public sector, to be able to make those informed decisions. Specifically, how we can help get to insights faster, there's 3 ways we can help. One is providing access to a data catalog. I'll talk in a minute about a key capability that we just introduced commercially. It's called the Google Earth Engine, which is a planetary scale Earth observation platform. We also have a number of public data sets, or we can actually use commercial data, or the data that government themselves collect. Government is investing heavily in remote sensing capability, so we want to be able to use that information as well. The second pillar of our platform is smart analytics, using AI capability, ML, using capabilities such as Compute Engine and Vertex AI, and all these technologies to really be able to power all this data. When we're dealing with planetary data and Earth observation, we're dealing with petabytes of data, so we need technology to be able to process this at scale and to be able to get to those insights. And last but not least is having a very strong ecosystems of partners such as Climate Engine, Carto, Acclima, and many others that are building very specialized capabilities to able to, on top of Google technology, to be able to make this even more streamlined. We have introduced two key capabilities for government. We call them Climate Insights. The first one is Climate Insights for Natural Resources, which is the work we're doing with Caleb and his company at Climate Engine. And this one is really be able to use satellite imagery and remote sensing data from an Earth observation perspective, and then applying AI ML on top of it to be able to get to those insights very, very quick so we can inform adaptation strategies, so we can accelerate science into operations to achieve the Vision 2030 that the Kingdom and many other governments have in place. The other thing we also introduced is Climate Insights for Infrastructure. This is applying the same technology, but really focusing on the built world, focusing on roads, focusing on bridges, and all the things that we need to make plans for. How do we best adapt those plans to ensure that we take climate risk into consideration? And we're working with Climate Engine and Carto on that as well. The technology perspective, I will go through this very quickly. We have a very strong geospatial platform. Google Earth Engine is the primary product. We also have BigQuery. It's a technology that powers all the searching capability that you do every day. Every time you search for something, BigQuery is what powers that. Then we also have Vertex AI to ensure that we help accelerate access to AI ML. Unfortunately, there's not a lot of resources available to us. There's no AI. These provide a lot of auto ML capabilities so you can actually develop much faster. And last but not least is the Maps platform to visualize a lot of this information, which many of you use all the time. And from an Earth Engine perspective, the key capabilities that Earth Engine provides, it's a platform that has been around for more than 10 years. It's been used heavily in research and academic settings. We have more than 100,000 researchers globally that are using it every single day to do their work. And we provide a very large data catalog of 800 plus data sets, 60 plus petabytes of data. We have 40 years of Landsat data, 40 years of Sentinel, and many others. And then we also provide computing capabilities. When we're dealing with satellite imagery, when you see soon when Caleb shows you those images, in order to produce those maps and those images, it requires a lot of data, and it also requires a lot of computational power. And that's where cloud computing is very, very helpful, because we now have tens of thousands of CPUs that we can do parallel processing and get these queries running as quickly as possible. And last but not least, it's a collaborative ecosystem. These researchers that are producing a lot of work with Earth Engine, they actually publish papers and they contribute back a lot of the data sets. So it's a very strong platform, and it's a very thriving ecosystem. We have an event called Geo for Good coming up in California. In a month from now, we have over 1,000 researchers coming in, talking about all the work they're doing. So it's a very thriving ecosystem. And just give you a sense of the type of data that we have climate and weather imagery, we have geophysical, and very strong data. And it's also continuously being updated. We put in new data sets every day, and we ingest data from all these sources every single day. And with that, I'll turn it over to Caleb.
Thank you, Franco. And I will say, I am very impressed to see the commitments that you're making on the clean and net zero commitment internally. I told my son I was coming here today to deal with AI, and he's like, Mom, you know, these data centers are increasingly bringing a lot of emissions in, so that's going to be your first question, so that's great.
Thank you.
Caleb, with this fantastic platform that we're seeing in terms of data, the computational platform, the ecosystems, can you tell us a little bit then about how Climate Engine is using these to create value?
Absolutely, yeah, thanks, Shelley. So I'd like to show you all a little bit of the work that we're producing in our lab and in collaboration with NCI and SDAIA and MUA. So we know the planet is facing unprecedented change. And we see this happening. Shelley spoke about this. You know, the extreme events that we're seeing are becoming more frequent, more severe, and it's only going to increase. And so our view of the world is that in order to protect our our planet and our ecosystems is that we have to continually monitor our ecosystems, our planetary changes, so that we can start building resilience and adaptation. And what are the risks? There's also opportunities. We can look to identify what are the economic risks of climate change. We can look to how do we optimize sustainability efforts, and how do we secure a safe and sustainable future. These are all big, broad questions, but they're ones that are faced by both the financial sector and our private sector, as well as our public sector, as we see these continual changes happening every day. So Climate Engine as a company is a scientist-led company. Our chief founder is a PhD in hydrology. Our team is made up mostly of earth sciences PhDs that specialize in remote sensing technology, remote sensing earth sciences, big data technology. And we've built a platform on top of all the great Google Cloud components, which actually has only been released in the recent months. At the Google Cloud Sustainability Summit, Google announced that the core technology, Google Earth Engine, is now available for commercial use. And so Google's really leaned into the commercial space, and why we've partnered with them and built our complete company on top of Google technology is because they organize the world's information. And now they're able to organize all of this incredible satellite information and meteorological climate information for companies like us to take advantage of and derive insights from. So this is an example of some of the outputs that we're producing for our friends at NCI and SDAIA. This is a map of Riyadh, and we've actually mapped land surface temperature to millions of buildings across Saudi Arabia. And we can do interesting things going back in terms of space and time. And what we're seeing here is that there's certain areas of the city that are incredibly hot and certain areas of the city that are cooling. And we can actually track this over time, so we can do trend analysis over the last 5 years, the last 10 years, the last 20 years to see which areas of our country are getting hotter, which ones are cooling, which begs the question of why. So when we start looking at smart cities, greening our natural infrastructure, re-greening the urban landscapes, all of these questions start to become available in terms of building resilience and adaptation. This is a time-lapse view of Riyadh over since 1985, and you can completely see the built-out of the urban landscape, which is really fascinating because, with the incredible technology that Google's bringing to the table, we have the ability to go back 20, 30, 40 years at times and look at all of these different trends and how these changes have taken place across the entire world. This is one that was suggested to us by SDAIA. You'll recognize the name in olive production, but looking at how these agriculture fields are greening up and greening down, it is really fascinating to actually start to derive why these changes are happening and to whom. This is a measure of vegetation health. So what it is measuring the robustness of the vegetation over time. And you can see green is actually greening up, and if it's not green, it's actually drastically decreasing. And we can go back and compare this over the last 20 years and look at how this is trending over the last 10, 15, 20 years, and then compare that to how that is reading in real time as new satellites and new data comes down from the sensors. And so even though we can go down to the field scale, with open data, it's down to the 10-meter resolution, we can also zoom out to the entire kingdom and to global scales, which is incredibly fascinating. And you can see the areas of the agriculture fields in the kind of the northwest and the southeast get really, really green. And you can, looking at these maps, this was never possible upwards of 5, 10 years ago. Our chief scientist has been doing remote sensing for over 10 years, and some of the stuff that we're doing in our lab, he would have been laughed out of the room that you could do that even 3, 4 years ago. But with cloud technology, we now have the ability to do all this multi-parallelized processing and be able to crunch this data, petabytes and terabytes of data, so we can start deriving insights from it. This is a measure of drought, and looking at this across regions, we were talking about food security earlier. So in our global supply chains, we're seeing drought affecting massive, massive economic consequences across supply chains, manufacturing, cases that you wouldn't even think of. We saw droughts in Taiwan affecting microchip production because of the water shortages. We're seeing droughts in Brazil affecting beef prices in Japan. So we're trying to connect place-based indicators. We know that there's changes happening on planet Earth, and we're trying to connect what's happening at planet Earth to what it's impacting at that location. It could be a manufacturing facility, it could be a road network, it could be an agriculture producer, it could be a manufacturing facility, it could be a hospital. It's all these different impacts that we're trying to track across the world. Another example is water use. So we can track water use in agriculture and looking at what does this look like over time, how much water is being used, and how does that changing over time from a trend perspective. This is an example in Peru in terms of deforestation. So we have the ability to go down and look at, in near real time, deforestation patterns and alerting for deforestation. But when we talk about marrying up the capabilities from a remote sensing perspective and what the satellites are seeing to what's actually happening on the ground, we can also map the asset locations of things like mining concessions. And we can start looking at, okay, where was the deforestation happening and which mining concession and who owned that mining concession? So we can start getting down to attribution and to actually impact our economic systems. So we see these risks happening to us from a planetary perspective, which we need to react and build adaptation measures. But we're also doing negative things to the environment, which in case we can actually start to monitor and start to introduce and be proactive at introducing good behaviors. I think this is a video. Oh, the video didn't play. I don't know if it... Okay, we can share the video later maybe, unless is it on the slide deck?
Maybe we do the video.
Okay, well, we can do it later. So that's it for me. Thank you very much for your time, and looking forward to the discussion.
It was great, and I think it's so inspiring. And one of the questions that we have now, and I'll bring to you as you do your introduction, Abdurrahim, is how do we take all of this powerful data and analytics and actually really build out local ecosystems that are needed to bring this to life and to actually unlock value in countries, not only like Saudi Arabia, but others. Can you maybe walk us a little bit through what does that ecosystem build look like, and how do the players that we all have in the room today participate?
Thank you, Shelley. And if you allow me, before that, I would like to speak, about an observation I just noticed now, because it sounded very easy. What we have, done together with, Dr. Abdul Hamid and the other colleagues from Sadaya, because, really it was easy. Quickly we showed the maps of the green area in Saudi Arabia and how they changed over time, and we have done so much of analysis in the last few weeks. But reality is, in the beginning, as Caleb was saying, most of those tools were not yet available. Yeah. And while we were learning, together as a team, together with Sadaya and Miwa, the products were actually coming out, and there was, a lot of effort by the local teams from, Miwa, Sadaya, and also, Google Cloud and Climate Engine, and how to put this together. And I remember my first meeting was with Dr. Majid Al-Tuwajiri from the CEO of NCAI, and he explained to me, it was my first visit actually to any client here in Saudi Arabia. So the first thing he explained to me is how we want to bring AI to every organization in Saudi Arabia, and not necessarily to the government or the public sector, but also to the private sector. And he said the best way to do this is to talk to every sector or every client with their own language and try to find out how AI could solve their problems. And he gave me an example of healthcare. They started already healthcare, and they started already projects around AI in healthcare. And the second, he said, we then started the energy section, and we wanted really to bring things in the energy section. And I asked him, what's next? I mean, he also mentioned a few other sectors. He said, next will be the environment. Would you be able to do something there? And I went back. It was really like a great challenge and a great also opportunity at the same time. So I went back and I sat with our senior consultant who was helping me. He's also sitting in the third row in the right-hand side. And I asked him, we have a lot of tools, but how can they solve this problem? How can they help in building this environment center that will help the ministries like Ministry of Environment and Water and Agriculture, but also the other private organization in developing, utilizing AI, artificial intelligence and machine learning to solving real life situations, and to help them and to help the policymakers as well, knowing that Vision 2030 addressed many of those changes that we are going through, and try to and provided like a solution to solve them. I'll give you an example. The Saudi Green Initiative is a very huge initiative, which is basically increasing the number of trees in Saudi Arabia until 2030 by 10 billion trees. This is a big project. I mean, compared to whatever is done around the world, it's by far one of the largest projects. Imagine on top of that, the Middle East Green Initiative, which will make it above 40 billion trees. So how would this help? I mean, the vision is trying to help. The vision and the other programs by the government is committing to having Saudi neutral carbon or carbon emission free by 2060. And how can those very nice initiatives can be a good use cases for us. We had a lot of sessions together with NCAI, and the results came is that yes, we have a lot of information. We have 40 years of satellite images that Franco was talking about. We have access to other satellites as well, in case we needed satellites with very specific data about emission or about other type of information. So we wanted to take all of that, and we wanted now to do little more, to make it more relevant to what we're trying to achieve in the Vision 2030 initiatives, and how we can help in all these programs. And not only that, also we wanted to see how we can utilize AI and more of AI. And the solution came is that we have a partner that already developed so much of activities in North America and Canada. So how we can put all of this together. And this is basically, I said all of this to answer your question, Shili. We developed the ecosystem is by first bringing the technology and bringing the consultants from those organizations that have been in this type of technology for a long time, like Google Professional Services Organization, where we have our consultants, but also bring the specialized companies like Climate Engine and other Google partners that understand the environment and the sustainability, and also partner with organizations like Sadaya NCAI, who have real top-notch experts in artificial intelligence and how to drive this technology and benefit the local sectors and the local organizations in Saudi Arabia with the real experts. The real experts are the Ministry of Environment, Water and Agriculture, who understand the pain, who understand the solutions, and who try to drive those nice strategies along many number of years. So that's how we bring the ecosystem. We put those two things together. We work in these type of centers with together with our professional services, our partners, and also with the Saudis from the ministry and from the other, like the artificial intelligence, center. And with time, we try to engage the local community and the local business community. And I hope, and I really hope, that we see new businesses right now as a result of this center, starting in Saudi Arabia, developing applications on top of Google Map and on top of Google Earth Engine that will really use, artificial intelligence, will use machine learning, and will make the job of everyone that cares about the environment, about sustainability, very easy with time. And this is basically how we bring the ecosystem.
Thank you very much. It's fantastic for us as we sit here today and we listen to everything that's happening in terms of the climate strategies, the technologies and platform, the ecosystem, and that's all coming together in a commercial way. What we will do now is open up for discussion and question from yourselves. So I give you a minute to think of, we have one question already. Excellent, thank you very much.
Thank you very much, panel, and for chairing this session. I'm the Director for Science and Innovation and the Chief Scientist of the World Meteorological Organization in Geneva. And I just wanted to ask two questions, the one to Franco and the other one to the colleague on the right side. I think it's important when you talk about all these Earth observations and the role that Google is playing to acknowledge and to appreciate the role of national Met services, World Meteorological Organization, Copernicus, and all the weather centers, World Climate Centers that provide actually the data to be used for you for free. I think that's important, that this is something we need to acknowledge. And I think it's also important to realize that these national Met services, they provide the infrastructure and sustain it. So the first question would be, and also geo-ops and so on. I wanted to ask you, I mean, Google takes all this data for free and provides services. The question is really, we have a lot of areas across the world where we don't have observations that are important for better weather predictions, weather forecasts, and also in the long term for assimilation and climate projections. And we have a lot of countries that do not have the capacities to do that. So what we do from the World Meteorological Organization with other organizations and also stakeholders to make sure that in the long term we provide these observations, the critical infrastructure to come up to better predictions. So I wonder if Google might also think of playing a role in providing financial support to maintain and sustain long observations in areas that are not covered yet. So that's the first question to you. And the second question to your colleague on the right side would be, Guterres, UN Secretary, mentioned the 23rd of March that within 5 years, 100% of the population on Earth will be provided with early warning systems. And he mandated the World Meteorological Organization and some other partners to come up with a roadmap towards these 5 years at COP26 in Sharm el-Sheikh. I just wonder, how is the situation here in Saudi Arabia in terms of early warning system, and how do you make sure that the last mile of predicting the weather conditions for an extreme event, that the information, the alert warning system is actually received by the public? Thank you very much.
Thank you very much. So maybe, Franco, we start with you, and maybe to recap the question, because we got two questions there. It's really what's the role that Google is going to play in these, let's say, marginal communities that might not have the financial, means for monitoring.
Yeah, so great question. First of all, you're absolutely right. I mean, the data that comes from Copernicus, from Landsat, and the others, it's a great investment from government. What Google provides is capability to access it. It's data that is available to everyone. What we do is add value to it by bringing it in and allow you to query it instead of having to download and be able to manage the data yourself. That's the key value add from Google. And regarding investments in other parts of the world, Google has a number of philanthropic activities that we do. It's google.org, and we have a number of climate initiatives that we have investing in, and we are going to be at COP27. There's a number of new initiatives we'll be in. Specific to what you described may not be 100%, but there's a lot of different activities that Google is doing from a philanthropic perspective to help with this as well.
Yep.
Great question. Thank you.
Yeah, and maybe before we go to the second question, I think it's a good one for you, Dr. Abdul Hamid, to talk about how you see that balance between private and public sector.
Right. He was asking about the early warning center. As you know, in MIWA we have early warning center in Jeddah. It covers all the and protect all the weather changes, all the disaster that may happen from earthquake or etc. And it has very advanced and calibrated technology right now. Today with this project, I think we will empower that center with our partnership here between climate change and Google Cloud. And I think this is a long journey to take this center to an advanced technology based on enumerative technologies and advanced AI technologies.
Yep. And maybe just a follow-up question for you. How do you see the balance of investment and focus between public entities and the private sector? Like, where do you really need the private sector to step in?
Yes, I think nowadays the balance has changed. We have more than one module to make a partnership between the public sector and private sectors. one of which is financing the projects. The other one is like have share revenue. It depends upon the what so-called feasibility study. And we have some projects that have this approach, share revenue between the private sector and the public sectors. It depends upon many factors here. We talk about the financial factors and how we ensure that we have win-win model between the private sector and the government sector.
Very good. Caleb, did you want to come in on the climate engine perspective?
Yeah, I think that the question was an excellent one about open data and open science, to be honest. So Climate Engine, I think our view is that not one organization in the world is going to have all of the knowledge in order to solve the crisis that we're in. And
Yes.
so we're going to need the best and the brightest from all organizations, both in the private and the public sector. We lean very, very heavily into open science and open data. So thank you to the WMO office for all the contributions. And I think the government sources of this type of information is critical in order for sound policy making. And one of the things that we stress most importantly is data and model defensibility. So when you're going to the corner office to make policy decisions or make financial decisions in the economic sector, you need to know that it's based on sound data, sound modeling, and sound science. So I think that the black box approaches are going to be challenged moving forward in lieu of having an open and transparent methodology and data from all sides.
Good. One more question.
Thank you very much all. Mohammed Al-Alwani, Aramco Saudiya. I do have a question to Abdurrahman Bawazir. Abdurrahim Bawazir. So you talked about the emissions. I would like to get more knowledge about what is the current capabilities. Are the current data would be able to distinguish between the different greenhouse gases and quantify them, or still it is in development stage right now?
Okay, I wish you gave this question to someone else, but I'll try. Again, you know, Google Earth Engine is providing a lot of data, but also providing the satellite images from certain providers. And we are, and how Google Earth Engine is designed is also allows satellite images coming from other satellites, commercial satellites, for example, and you can still run them, and you still run a lot of foundation analysis and tools, and even based on AI from Google Earth Engine. On top of that, what we are doing right now in the center is we're bringing Climate Engine that are bringing more AI tools that can also be customized and can also be developed to produce more insights and to analyze, you know, different use cases in any way you want. You know, I have attended many, working sessions, and I have seen how this complex, having this huge, terabytes of data with satellite images for the last 40 years or so. In addition, if you added more satellite images from other sources, and how you can, be lost with all this data, and how when you apply the tools that Google Earth Engine provides or the, Climate Engine provides, how you can easily focus on whatever number of days of the year, any number of years, any months, and you can focus on any geographical area, and you can generate whatever data you want. And if that type of algorithm is not ready, it can also be developed, and it can be also somehow worked on and addressed to give the right insights that is required. So. In general, the center has been designed in a way that is giving all the tools, all the technologies that are available and that are already being produced, but also gives the opportunity to develop even future, technologies and future, customization. So to add more, I would like either Franco or Caleb, to comment, on how we can basically recognize if, the emission is, where is it coming from and the sources of these emissions?
Sure. So there's one thing to note is that the domain of remote sensing in the last 20, 30 years has been primarily the public sector. So the European programs with Sentinel and so forth, and the Americans with Landsat, MODIS. But we've seen an exponential growth in what's called the small sat or the CubeSat marketplace. And these are private sector companies that are putting up satellites literally every month by the hundreds. And they're putting up sensors of all different kinds. There's sensors going up and then in space right now to measure methane emissions. There's a partner that we work with called GHGSat that's doing that. They're out of Montreal. But there's also open sensors from the Sentinel program that can track it. So it comes down to a question of attribution and scale and resolution. So when we're trying to get down to the facility attribution, it often requires a much higher sensor. As opposed to managing and looking at plumes at a kind of much more coarser resolution. So one of the things that we talk to a lot about with clients is that with this growth of in an exponential way of the satellite marketplace right now, there's more data than we can shake a stick at, and that's only going to increase. So we need to set up the infrastructure, the technology systems, the production systems to take advantage of all these net new capabilities that are coming on stream every quarter. And so that's a lot of the groundwork that we're laying with Sadaya and MUA right now, is to lay that technological foundation so that as new sensors come online, it's everything from thermal to infrared to optical to radar to emissions monitoring. There's you name it, the sensors are going up. So we're going to have ability to monitor planet Earth like never before. And so we're super excited about it because I think that's our way to build resilience and adaptation, is to have our finger on the pulse of the planet Earth systems.
The other thing to also keep in mind, a lot of the data, government organizations, government agencies, they're producing a lot of their own data. They're using drones, they're using all kinds of in-situ networks. So there's a lot of data that is being collected at the agency level. We can bring that data in as well. It's combining all these data sources that we've been talking about, the public satellites, the commercial satellites, and your own data, and doing it at scale, and be able to have the platform that allows you to run queries in seconds and minutes versus some of these queries can run for weeks and months if you don't have the right platform. I think that's where the exciting opportunity is. The fact that we can do this analysis very, very rapidly. We delivered a project with CAI and Sadaya in weeks. This would have been taking us months and years to do in the past. Having these capabilities is really what will make the difference. So because ultimately what we need to do is we need to put the science into the hands of people that are making decisions in operations. We heard before during the main presentations, giving information to the farmers real time on what to do, what to water, what to do. Those are the kind of decisions we need to have available to the users at the time that they need to make a decision. That's where all this data becomes very, very interesting and becomes a great opportunity for us to harness.
Franco, that's quite powerful, and maybe I'll take that as a lead to give one question to each of the panelists to answer, which is, we're going into the COP that's coming up. All of these private and public sector entities are going to be coming forward or coming together to work on climate resilience and a number of different topics. As we move forward and we bring together technology in the name of climate, maybe I start on that side, Caleb. If there was one big priority that you would like, the world and the private and public sector to take on, what would be? So the question for each of you is, what is the main priority that you would want us to take forward on the topic of technology and climate resilience?
I think the ability to connect two disparate systems is what we're trying to do. So our planet is changing literally every minute of every single day, and our economic and social systems are changing every minute, every single day. But they have not been connected from a data perspective. So that's our mission, is try to connect that as quickly as humanly possible so that we can start pricing in risk, building sustainability, and connecting these two worlds so we can actually build a planet that we can live on.
Thank you. Connectivity of systems.
Thank you. I would say, that this center is now the very beginning for multiple use cases that would benefit not only the initial steps that we took, but also to use this capability and to use this technology and extend it towards more use cases, whether in the protecting the nature and the environment, or in the climate itself and trying to understand the climate and the behavior of the climate and predicting the future. in food also security and in supply chain monitoring, because the capabilities we're having are global capabilities. So they are not limited to one single specific
use case,
farming area in Saudi Arabia or a city in Saudi Arabia or the entire country. These are global tools that we can utilize and start monitoring the food supply chain across the world. The last one I would say is in the in the emission and in the pollution monitoring and analysis. That would be great. So what I would like to see is to expand that center to address more use cases, and also I would love this center to be one day a real big center, that not serving only Saudi Arabia, but serving the rest of the region and maybe the rest of the world.
So I just continue what Abdul Rahim talked about, the importance of this center of excellence that Saudi Arabia is establishing. It's the first in the world. I mean, I've worked in many countries. Nobody's doing this to this scale. I think we need to replicate this model in other parts of the world. If we really need to solve this problem with climate change, we need to think globally, how can we work together across private sector and public sector to apply science? And we don't have all the knowledge. The government has a lot of knowledge. How do we all work together to solve this? And I think I recently watched a TED Talk, and the topic was, we can no longer afford the fact that somebody else will take care of it. We have to all take care of climate change. It's no longer somebody else's problem. It's all of us jointly need to find a way of solving this. And I think we have the technology, with the willpower, working together, I think we can solve it. It's an opportunity.
Thank you.
Yes, I think the challenges in our sectors, the environment, water, and agriculture, are varied from sector to sector. But the main challenge is how to increase the green area, the vegetarian area. It's very important. Also, when we talk about water, how to save the water level. As you know, we have consumed water by farmers or by at the civil houses. And this consumption is very high according to the average of world consumptions. One of the challenges that we have faced now because of many events that happened all over the world is how to have a food security, secure supply chain also, secure the production, how to increase the and save the resources here with investing outside the kingdom. As you know, we have a company called Salik. It's under the MIWA. This company tried to invest on some countries that are good in some products like rice, carbs, etc. And we are investing, as you know, outside the kingdom. And with that, I think we need to use some smart solutions, very important. And this is, I think, one of the steps toward these solutions is launching this center today with our partner. This is, I think, basically what we are facing right now.
Good. So thank you very much. With that, I'd like to bring it to an end. I think we got great closing messages there. The power that the Center of Excellence will bring to us and the fact that it will be a lighthouse globally. And we look forward to seeing that growth as we go forward. The need to drive further collaboration across sectors overall, the need to scale our use cases and technologies, and overall the need to connect and drive connectivity between systems. Thank you very much to our panelists and to our audience for being so interactive with us. It was great to be with you today. Thank you very much.
Ladies,
on AI and cognitive cities. My name is Ben Quaiser. I am the head of innovation at Oxagon, and I am here joined with a panel of experts, starting with Anthony Butler, who is the Chief Technology Officer and Distinguished Engineer of IBM Consulting. Our very own Alessio Garofalo, who is our Chief Technology Officer at Oxagon in NEOM. And last but not least, Simone Venacchia, who is the Digital and Technology Consulting Senior Equity Partner at PwC. So we want to set the scene a little bit about, as you know, NEOM and specifically Oxagon are also built as cognitive cities, and how AI actually plays into that and what that means.
To Oxagon, the gateway to advanced and clean industries in NEOM. Fusing principles of Industry 4.0 with the circular economy to create factories of the future for products of the future.
To pioneering innovation, bringing the world's brightest minds together to accelerate ideas from labs to market.
To enhanced connectivity, building one of the world's most efficient and sustainable ports, strategically located in the Red Sea.
To seamless delivery, harnessing the world's first fully automated and integrated physical and digital supply chain.
To thriving communities, creating a new paradigm for living and working, where people and technology come together in harmony with nature.
Oxagon is the gateway to a brighter future.
Join us on our journey.
So, as you can see, or as you may know, with NEOM and its entirety, there are several regions, and Oxagon is the only industrial region within NEOM, which means it's the only place where industrial activity will happen. In line with being a cognitive city, built and as a DNA running through all of it is obviously AI. However, with being an industrial city, and you can see our vision up here, we will be the beacon of light and setting examples of clean and advanced industries for the future. So times are gone and times are on the way from smog, from industrial smog that you envision when it comes to industrial cities, but we're based on advanced and clean industries, which obviously are based on research and innovation together with the next integration automated supply and support chain. Now, Oxagon itself is built on 5 strategic pillars that you see up here. Advanced and clean industries, I already mentioned, in line with environmental sustainability and powered by 100% green energy. research and innovation, because if we are honest, anything that we have, and no matter how far we think our products and solutions are advanced, they're not advanced enough in order to fulfill our ambitious goals and objectives, right? So we need to research and we need to innovate with partners in order to achieve those goals and objectives. Next generation port and integrated supply chain, which is fully run on an AI platform, by the way. It is important to mention here that being the industrial hub, not only of NEOM, but of the kingdom, is these integrated supply and support chain by being powered through AI, but not only powered through AI, but sustainably being powered through AI. And we'll touch on that a little bit as we go through. And most importantly, our urban communities are what we call exceptional livability, because as much as we want to participate and to thrive in doing business so that we can achieve our goals and ambitions, not only as NEOM, but as a kingdom as a whole, in line with Vision of 2030, we want you to live there and have an exceptional livability with your family. So without further ado, and setting the scene a little bit how Oxagon and NEOM can come into there, I will hand over the baton to Anthony, who will tell us more about reading the future through AI.
Thank you. So what I will talk a bit about today is how a city can start to get a sense of place, how a city can become more cognitive, and how supply chains, which is particularly relevant when we talk about Oxagon, can become more intelligent, can predict the future, and can become more resilient as a result. So if we talk about analytics and artificial intelligence and time and place, analysis applied to spatial and temporal characteristics is not something new. If you go back hundreds and hundreds of years, if you go back thousands of years, you find that human settlement followed a certain analysis. People, our predecessors, would not establish towns or villages in places that would flood. They would think about where there was proximity to food, and so there was always this consideration around location and time that goes back really to the beginning of human history. And to give a more recent example of what becomes possible when we start thinking about time and place, I will give you a more recent case from London. So what you can see on this slide is Broad Street in Soho. And this happened several centuries ago in the midst of the cholera outbreak. Cholera was a disease that was killing many people around the world. And at the time, if you were to ask people what was the cause of disease, they would say it was caused by something called miasma. Miasma was the concept that disease was spread by smell. There was no understanding of germs, there was no understanding of bacteria, there was no understanding of how other factors like food and water could contribute to the spread of disease. The person that you see on this chart is someone called John Snow. He was a physician at the time in London, and he took this map of Soho and he started to put points, dots, where people were dying. And as he did this over many weeks, many months, he started to identify clusters. He started to identify that people tended to die around the objects that you see on the far left-hand side of this diagram, which is a pump for extracting water. And as a result of this, two things happened. Firstly, he was able to stop the cholera outbreak spreading in London simply by breaking the handle on the pump. Secondly, we moved our understanding of how disease is transmitted forward by understanding that it was now being caused by germs, in this case, germs that were in the water that was coming out of this pump. So we moved away from thinking about this concept of miasma to thinking about how germs and bacteria contribute to the spread of disease. And this was all through a very early application of analytics to geospatial data. And this is something that continues to be extremely important today as we think about sustainability, we think about how do we manage supply chains, we think about how we manage food security. The role of geospatial data is becoming far more important, and the possibilities are becoming far more sophisticated as a result of the advent of different technologies. And there's really three drivers of this. First is we have much more advanced sensors. So we have, for example, hyperspectral cameras, and you can think of it as a camera that can see the radiation that's emitted by different materials, okay? So satellites are now equipped with some of this hyperspectral imaging, so it's not just looking at a map like you would see in Google Maps, but we can actually see the light that's being given off, we can see how certain atmospheric characteristics are contributing to things, so we have much more visibility through remote sensing technology. And obviously this is creating a massive amount of data. So the advent of cloud technology is also helping us process some of this data. So we have the emergence of platforms. And you can think about satellites and drones as an additional type of platform, where we're able to deploy different sensing technology to these platforms. And through that, we're able to get more visibility. And then we can scale. So we're at an inflection point where a lot of these things are really coming together and becoming much more possible. The challenge that we have is that most organizations don't really understand the potential of this particular type of data to transform their business. And it doesn't matter whether you're an insurance company, whether you're a bank, whether you're a city like Oxagon, whether you're operating a global supply chain, whether you're an agricultural company, there is value that can be created through the analysis and the leveraging of this unique type of unstructured data. The first challenge that we have is that the amount of data that gets produced is huge. Every day, petabytes and petabytes of data is being produced by geospatial satellites. It's being produced by other IoT devices, and we estimate by 2025 alone, over 180 trillion gigabytes will be produced by IoT sensors. So all of this data imposes obviously a massive opportunity, a massive challenge, but also represents a very significant opportunity. The other challenge that we have with this type of geospatial data is that the structure that it takes is often not the typical type of structure that people are used to dealing with. So we have rasters, we have 3D vectors, which is something that is generated by LiDAR sensors, and of course a lot of it is time series data. It's also important to remember that to understand this data we need context. So going back to the example of Jon Snow, if he had a blank sheet of paper and he was just drawing deaths against an X or Y axis, it wouldn't mean much. But when he overlaid the maps, he was able to determine that it was caused by this particular water pump in Broad Street. So it's also important that we're able to add context, okay, to the geospatial data. So you can see these dots. These dots in this particular case represent CO2. And it's only when you overlay the roads and the industrial activities that you can start to make sense of it. The other challenge that we have is that the data is poorly indexed. It's very difficult to search because of the different types of data that we're talking about. So as IBM, one of the interesting developments over the last sort of half decade is we realized that weather was something that it touches everything, whether it's supply chains, whether it's insurance, whether it's demand for retail products. And so we acquired the weather company several years ago. So almost all of you, if you open an Android phone or an iOS phone, the weather data that's being provided to that phone comes from IBM. And people always wonder, why as IBM would we get into the weather business? And the reason really became apparent in the last 2 years when we started to see all the disruptions from COVID, how supply chains were being adversely affected, and how we can start to help companies and cities and governments become more resilient. And so now what we have is a platform where we have a curated set of data sets that we're pulling from over 450 sources, not just sort of classical imaging data that you might imagine coming from a satellite, but also spectral data, weather data. We built a predictive model extending to the year 2100 that allows us to predict the likelihood of flooding, the likelihood of adverse weather conditions, and this can be used for all sorts of possibilities. And we constructed it in a way that entities like governments and private sector firms can start to index it, can start to query it, can integrate it with their existing data sets, and can do that to create many new possibilities. And I'll give you just 3 examples of real-world examples of how this type of data has been used to create value that would have not been possible had they relied on traditional data sources. So the first example is it's actually a fertilizer company. And what they wanted to do was to be able to predict demand for fertilizer products. And in order to do that, they had to get a sense of how much grain, how much wheat was being planted in different parts of the world that they serve. And you can also apply this same use case to food security. So firstly, using geospatial data, satellite data, we could identify where the farms are, we could identify the fields. Using spectral data based on the color that's emitted and the image recognition capabilities of AI, we could say that they're growing this particular type of grain, and based on the color that's being emitted, we could estimate the health of that product. And based on the health, we could predict the yield. So we could say this farm is likely to produce X amount of dates, X amount of grain, X amount of wheat, based on the unique characteristics that we were able to observe through this geospatial data. So this allows us, obviously, to be much more precise around food security, and it allowed this particular company to have more visibility of demand for fertilizer. A second use case is around risk modeling and insurance. So I mentioned that weather touches everything. So the ability for an insurance company to predict many, many years into the future at a very, very granular level. So we're talking about, in some cases, 5 meter by 5 meter radius. We can predict the likelihood of rain, the likelihood of flooding, the likelihood of excessive temperature. And so for a global insurance company, this was very valuable because it could help them better understand and model their own risk, but they could also, in this case, provide it as a service to others who want to perform more precise risk analytics using this weather data. And the last example that I will talk about is an electricity company, and one of the challenges that electricity companies have is vegetation that interferes with the transmission or the distribution infrastructure. So a tree or a branch or overgrowth of a bush or whatever can create a fire hazard, and it can interfere and create risk. So using some of the data that I described, we were able to predict, based on weather, based on the geospatial characteristics, based on the geological characteristics, where there was likely to be a problem with vegetation increasing or growing at a pace which would render a threat to some of the physical infrastructure. So this is another example within the utility sector, how weather has been used. And now if we think about what this means for a cognitive city or what this means for a supply chain, you can start to think about all the possibilities. You can have a supply chain that will be intelligent, that will be able to predict when there's likely to be adverse weather conditions, that can predict demand when you have demand for certain products, for example, influenza vaccines or influenza treatments, which is in some sense tied to weather conditions. So you can start to see how a cognitive city can be better informed by some of these geospatial and weather data sources, as I've mentioned. Thank you.
Thank you very much, Anthony. And with this being an interactive session, I would like to take it to you, to our audience. Do you have any specific questions right now around what Anthony just showed? If so, there should be some roaming mics around you. Just raise your hand, please, and then we'll make sure that you get a mic. Anyone? No? All right, then I have one for you. So Oxagon and NEOM as a whole, as you are aware, at the very heart and core of everything that we do is sustainability. So how would this actually contribute to a sustainable future of ours that we're trying to achieve so hard?
Okay, so I think there's I'll give two examples of how this type of technology and this type of data could be applied to address sustainability concerns. The first would be the remote sensing aspect that I mentioned at the beginning. So the ability to look from the sky and identify where there is CO2 emissions, other greenhouse gas emissions, and be able to link that to activities. And so you start to build an understanding of, if you do this at this time, this will have this impact on CO2. So I think that's definitely one obvious area in which this type of technology could support with sustainability objectives. The other, if we talk about so that's kind of from a greenhouse gas perspective. The other could be with respect to food security. So if you know where your food is coming from, where it's being grown, and it may be that it's within the country, it may be that it's somewhere outside, but using this same technology, you can predict the likely amount of food that will be produced. So then you can start to mitigate food security risks ahead of environmental or weather-based disruption. And then there's many other. I think there's many other examples that could be spoken about. But certainly sustainability is one of the areas where this type of technology can be applied very effectively. Thank you.
Fantastic. Thank you. With that, I'll open it up again to the floor. And we do have a question here. If we could just please have a mic, please. Thank you.
Thanks for you. I see that you spent a lot of time talking about use cases of, first of all, my name is Nadir Garaibe. I'm associate professor at Tiba University. Yeah. We see a lot of use, you explain a use case about cognitive cities, but you didn't talk about what type of ecosystem, AI ecosystem that is used in these cases. I mean, this large quantities of sensors needs a lot of IoT system sensors like Wi-Fi. Also, these sensors or these input data must be ingested into what? Into a big data platform like Hadoop or something like that. Can you talk about this issue further? As you are talking about cognitive cities, we expect from you to talk about community and society, specifically social media data that come into play into this big data or this AI ecosystem. Again, thanks for you.
Thank you very much. So I think this is a broad question, right? But I'll kick it off with Anthony, and if any one of the two gentlemen would like to add afterwards, feel free.
Okay. So in general, if we talk about a cognitive city, it will be, by definition, it will need to bring together an ecosystem, right? Ecosystem for multiple dimensions. So let's start with the data. So the collection of the data needs to be pulled from multiple sources. So some of it, even if we're talking about satellite data, some of these will be specialist satellites for CO2, some will be NASA, some will be national satellites. So over 450 sources of data will come in just from a pure satellite perspective. But then you have all the sensors, you have connected cars, you have connected warehouses, you have robots. So think about all of the things that data will be sourced from. This is one aspect. And all of this will require an ecosystem, right? It'll require an ecosystem in terms of the sensors. It'll require an ecosystem in terms of the collection of the data. But there will need to be standards that will also be considered so that everything can be brought together. And then once you have all this data, how do you create value from that data? Again, this is where an ecosystem should come into play, right? It shouldn't be one company that's taking the data and building products from it. This data is data that can be used to enrich use cases that span healthcare, supply chain, travel and transport. And this is an ecosystem because you have different entities within that broad spectrum that will benefit from this, right? So I think by definition, this is a very much an ecosystem discussion.
And I think also another important element of the discussion is definitely understand the technology behind, right? You need to support anyway the gathering of the data with the right solutions, the right connectivity level. Okay? You need to understand and have a strategy of how much data you're going to put into those data lake, right? Or how much data instead you manage through the edge. You maintain at a higher superficial level so that you don't create too much noise, okay, in the cloud, and then you get like issues in managing all the data. Okay? Being cognitive will also means being selective, okay? Being understanding which are the data that you want to leverage for then fulfill certain kind of user experiences, right? So I think that is where we're putting really a lot of effort in identifies within a community, within a specific assets, within education, right, or within manufacturing, which are the different use cases that make us cognitive. Okay? And from there derive, if we want to do that use case, then which kind of sensoristics, which kind of data, where is this data coming from, and how do we manage that? So I think this is an extremely important step that needs to be taken throughout the journey to be sure that anyway we will fulfill the vision of becoming like a cognitive city.
I don't know, Simone, if you want to add to that?
Look, I think they said it all, right? But just a very small consideration on my side. I mean, it's usually very difficult to manage this whole ecosystem in existing developments. Now, one of the real great opportunities here is that there is a lot of developments which are coming now, and they can be designed from the ground up to have all this ecosystem embedded into that. And they can be designed to be simple for this ecosystem to basically produce less noisy data, which seems like a minor thing, but it's extremely important in having this at scale.
Fantastic. Now, see, the first one broke the ice. Now the hands are coming up everywhere. All right, let's take one more question, but I'm just time conscious. We're going to have a Q&A at the end of it again, and we'll take one all the way at the back this time, please.
Hello, this is me, Dr. Hamad Alawad. I have a kind of concern about the system. We're trying to build a nice and good system in terms of help humanity. However, the system gonna be more complex, and we rise the uncertainty, and we rise the connectivity, which really hard to be thinking from different sides in terms of safety and security. How can we manage any crisis happening in such system? Thank you so much.
So I almost want to say that that is going to touch on something which our very own Simone will add to later as well. So if I can just take your question and put it a little bit time back, because as Simone is going to go through his presentation to you, I think it'll touch already on a little bit of what you're looking for, and if not, I'm sure he can explain in more detail. But without further ado, over to Alessio.
So good afternoon, everybody. First of all, it's fantastic to see like a full house for the session. Can I have the clicker?
You got it.
So when we are speaking about cognitive city, right, and Oxagon overall, the aim is to become the first industrial cognitive city out there, right? But how do we do it? Okay. We do it trying to create what Anthony was mentioning before, really a thriving ecosystems that brings multiple things together. So on one side, we have research, okay? We have innovations, we have technologies, all these components that needs to be tied together very, very well. Okay, very strategically. But at the end, what really matters is the humans behind, right? Cognitive doesn't mean anything if then does not make life better for the people, right? For us. So everything that we want to create for a cognitive city really needs to be, thinking about human first, right? Being anyway human-centric solution. I think this is very, very important. We don't touch enough on these topics. Technology is an enabler for people, right? And that I think is a very important step that we need to take throughout our journey. And if we look at a cognitive city itself, how do you actually manage that? Okay, so cognitive is so broad, has so many capabilities, right? It's so wide. Okay? And one of the important elements that we think it will be extremely revolutionary and very important to manage the city in the future is clearly digital twin. Okay? We see a lot the industries speaking about digital twins, but let me try to navigate you through the approach that we are taking in digital twin. First of all, for us, digital twin is also a way to conceptualize, right? To actually build something before it's even built for real, right? So why? Because we need that. You need, while you are going through a building process, something that help you understand if you're making it right. Okay? Something that help you to understand, is it actually going to come like this, these buildings? Is the space right? Okay? So these kind of capabilities are extremely important, and visualization bring you much farther than see things just like on paper, right? So the second element is to push boundaries of the industries. This is very emerging technologies, okay? Digital twin, streaming, XR, AI, okay? How can we actually leverage all this cross-functionally, to then move and create something that is one step further, right, of what you see as of now in the industry. And last but not least, how can you use it as a way to manage and monitor reality? So what happens on the ground, okay? You manage your traffic, manage the constructions, understanding your planning, planning ahead and so forth. So here you see some of the previews of actual digital twin of Oxagon that is already a reality. And we aim to use the digital twins as a way to run simulations, test different scenarios, and really help us to get insights from data, both data of planning and data of real things happening, right? So here again you see some of the pieces of our digital twins, but we started saying that we think at human first, right? So for us, digital twin is also a way to provide an immersive experience to people. Okay? We are not thinking about digital twin only as a business tool. Okay? We're thinking about tools for everybody. So in digital twins, you can actually then leverage immersive experiences, enter inside Oxagon while it's built, okay, and potentially go and shopping into a grocery store, okay, into the digital twin and receive this in reality. Then clearly, and you see some examples coming through the slides, we say this is a tools to monitor, right? It's a tools to understand what's happening in real life. Okay? So, we connected with the cameras that do time lapse on a daily basis, with drones that actually scanning the entire the tires evolutions of the areas, okay, so that you can actually see if what you planned for on paper is becoming reality in the right way. And then we use AI on top to understand things like is it this the right size? Okay, are we constructing it really right? Or is it progressing as per schedule? Okay. Is it installed late? Is there any risk? Okay. Are you going to identify through those cameras any safety risks? Okay, maybe in the construction sites. So very, very strong tools that can help you to manage and monitor the day-to-day base. And as I also said, it's also a way to create and value like the data that you actually are bringing within your organization. So you're collecting a lot of data, but then data is nothing if you then don't put it together very well and you don't transform it into insights. So on our digital twins, we brought the capability to manipulate the data, create different dashboards, create different views, understand the data that you have through, and then have a visualizations of the data on the plan. Okay? And you see it represented into a digitalizations of the master plan, or you see it on a GIS layer, so on a map, right? So that you can really understand in front of you how the data is really reflected into the real world. An example, how is evolving the constructions through time? Okay? Where is it that coming live specifically? It's also a way to somehow manage the more in depth some factors of the city itself. Mobility efficiency. So, for example, through a digital twin, you can understand if your networks of mobility is well designed, or if there is anything that needs to be done to change the way of mobility is working at that moment in times, or crowd management. Imagine you are in a museum, and through the sensoristic in the museum, you are able to understand if like a room is so crowded, and then modify the environment to then move more people into a more empty room, right? Okay. Or, as I was saying, managing and the constructions or the logistics of a city. And finally, the digital twin would not be completed if without people into it. So here you see my avatar, okay, I call it digital me, okay. And we think that is extremely important again to then represent the people within the digital world. Okay. We see the industry is growing so much. You see all the data that wearables okay, are helping to collect and that are influencing our own life, right? So now you can predict using AI to predict through the wearables, through your watch, if you will have a heart disease. Okay? So more and more this will become pervasive on all our life. Okay? And we will use AI to gather more information about our behaviors, how we are spending our money, our mobility, okay? How we do sport, okay? Our efficiency, our productivity. Okay? But it's not only about connecting data, it's also to give back to the people the possibility to actually control that, right? To manage it, to respect their own privacy, to know what you're putting out there, and to decide on yourself if you want to take and leverage those experiences, or instead, if your privacy is extremely important, you don't want to share this data with anyone, right? So it's important that in the new digital era, and with digital twins and digital myths coming through, now we have all this in mind while we are creating the futures of a cognitive city. So thank you. That was all from me. And I'll drop to you on any question.
Thank you, Alessio. So I will shake it up a little bit because I see there's already a lot of questions in the audience, just like there was before. So what we'll do, if that's okay with everyone, I'll just skip over to Simone quickly so that we have a real discussion with you guys on the floor where we can take more of your questions and not just one or two at the end of the session, yes? So please keep all of your questions in mind. We'll come to you, I promise you that. But now over to Simone.
Thank you. And it's great to be here. It's great to see the full house. It's great to be talking about this today. Basically, we just have 10 minutes, more or less. So I will just try to walk you through what it means to do a cognitive public safety at the urban scale, or on large scale. Let me start with telling you a bit of what public safety means, right? There is many things in public safety. One part is around law enforcement. It's basically policing, for example, or anything which is around making sure the rule of law is actually applied. So there is no crime, there is no risk for people, there is no risk for businesses. There is then one part which is around customs and border. Now, this can apply at the urban level, can apply at the government, or at the broader level of the state. Now, the idea here is how do you deal with potentially dangerous goods or people being introduced either in the urban level or in the state. And then you have all the area which is around non-man-made problems. So basically, how do you keep people safe from things which are not linked to people? So how do you keep them safe from fire, from natural disasters, from floods, from everything that you can think which is not coming from another man? And this is done by managing the emergencies, so basically dealing with things which are happening, but also preventing them. Just making sure that everyone is doing the right thing when building a new building, creating a new road, and the like. Let's go a little bit deeper in this. When you talk about public safety, we saw more or less what it means. Now we are looking at which are your stakeholders. So who are the people who are really touched by this? Now, of course, you have everything which is about institutions. So think about government buildings. Think about everyone who is running something for the government as an authority and needs to be protected because they have a sensitive target, because they may have something that can be taken from them. There is, of course, all the business area, right? We tend to forget it, but if you don't protect, if you don't implement public safety, it's very difficult to have a viable business, whatsoever business. And then, of course, you have all the residents and visitors. So basically, everyone who is either entering the city or living in the city and deciding to settle and make their own family live and thrive in the city. And last but not least, you have public officers. You have people who are really enforcing policing and people who are dealing with fire and everything that you can think about like this. Now, of course, the different entities have very different requirements in terms of what it means for them to be protected. So, for example, for people, the key of the story would be being able to live their lives in a safe environment which is trusted and they can actually enjoy it. On the other side, for the officers, the problem will also be doing what they need to do with the most of the automation in the safest place and in the best way. So we saw a little bit, and I mean, we will be happy to get any questions, right? I'm trying to go fast because we have 15 minutes, but we are happy to go deeper in all these topics. So we saw a little bit what it means to do public safety. We saw who are the stakeholders. Now let's look at what are the typical imperatives, so your own principles in making that cognitive. Now the first part is embedding a sense of trust in everything which is happening. Now, if you are a resident in a city, you don't want to see too much police because that's scary, right? You don't want to see too many weapons around. What you really want is to feel safe and to feel like everything around you is controlled, even if you don't have a huge presence of weapons and men. The second part is resilience. So you don't only want, as a citizen, to make sure that someone is basically prosecuting a crime, but you want the society by itself to be preventing this crime. And this is key to the role of cognitive, right? I mean, you can basically use cognitive, of course, as Alessio said, to do digital twins of the city and starting to understand which are the spots which are more risky, maybe close to a market, maybe close to places which are extremely populated, maybe close to places where you have a bank or you have any kind of things which is valuable. On the other side, you can use cognitive to see that people are experiencing strange behaviors. Now, if you are in a parking lot, you're not getting your car and you are looking at all the cars, there is a good chance you're trying to do something there. And cognitive, by analyzing the videos or analyzing the noise or analyze the time that you are spending looking for your car or the way you are looking for that, maybe you are getting too close, maybe you're looking inside the car, can actually spot a behavior which can be resulting in a crime before the crime is there. Then we talk about privacy. Now, privacy, as you may expect, is a very big deal, right? Now, we want to control society, but we want to help everyone to have the best of his life. So we don't want people to feel like we are invading them. We want them to be happy. We want them to do what they want to do without any intervention. We will see that in a bit, but there is a full plethora of different technologies that can help us out in this. Now, the idea is controlling people without knowing who these people are, unless there is a real crime. So basically, you want to know that a lot of people are running in one direction because that's a relevant piece of information for your cognitive engine to understand what's going on. But you don't want people to know who these people are unless there is a real crime. And there is a full set of technologies which are only aiming at exactly this. Invisibility. I saw that before, right? You don't want to see a lot of police around. What you want is that everything which is happening is actually happening without you having a lot of burden. And this is very important for the business, right? You don't want people to have to stop every single time, check their bags, do a lot of different things. You want them to go seamless and still be secure. And this is a topic which is actually, in general, a little bit overlooked. But we saw that when we were talking about ecosystem, right? Now, the reality is that all this works if you really have a central coordination. Now, when we talk about coordination, we will see that in a bit, is coordination at the autonomous level, but also coordination at the people level. Because you have a lot of different players, as we saw before, and they need to do the right thing in the right moment if there is an emergency. And you may actually miss the possibility to solve the problem if you don't do this in a coordinated fashion. Now, if you look at literature, there is many cases in which major disasters were actually creating even more pain because the forces like fire and police were not really coordinated and were not really able to work together. This part and the second part are mostly linked to the job of the officers, right? So the first thing is you want officers to be happy to do what they need to do, but you want them to be fair, and you want this to be implemented in the right way. So unless there is a crime, they're not supposed to be intervening in the life of citizens. And if there is a problem, you want them to do exactly the right thing. Now, what we're talking about here is how do you move this to the cognitive part? So what you want is your cognitive engine to be predictable so that if something happens, you know that the response will be the right response. And you also want your cognitive engine, and we can debate about this a lot. I mean, there is a full set of technologies for this. You want every decision of AI to be absolutely auditable, and you want to understand how the AI came to that point. Now, if you look at this, you will see this is a little bit futuristic, but a lot of the things that are happening right now in research in public safety using AI are about how do you enforce without the officers. So by using robots, right, or by using devices rather than people. And this is great because it's saving the officers from a lot of risk, and it's also trying to stop people before they are committing a crime rather than coming after the fact. But for this to happen, you need to make sure that what AI is doing is the right thing. And if you don't do this, you really miss a point. The last part, which is also linked to the back office of this, is basically how do you optimize cost? Because now it's great to do all this, but you want automation to be helping officers to be less and do the right thing, and you want everything which is solutions to be maintained and actually working in the right way. So let me go a little bit deeper in the technologies. Again, in the boundaries of times that we have, but if you have any questions, we're absolutely happy to take it. So let's start from the first batch of technology. This is about automation. What does it mean? Those are solutions which are getting what an officer is doing and making that less and less human intensive. So let me give you one example, right? In general, if you look at how the things were done, until yesterday, you have people looking at CCTV and trying to understand what are people doing. This is very inefficient because you need a lot of operators to look at a lot of cameras, and eventually they will sleep or they will lose their attention because it's an unforgiving kind of job, right? You need to look at the same thing over and over again all your time. Now, the point here is that you can automate this, for example, by having AI looking at movements, the AI looking at the way these movements are performed, and basically assign a score to what the people are doing. So that, for example, if everyone is running towards one direction, maybe it's just by chance, but maybe there is a fire, or maybe there is a problem, right? And that's why people are going fast only in one direction. Now, if you can start monitoring only at that point, you need less operators, and what the operators are looking at is something relevant. It's not looking at the same image over and over again. And this is, by itself, already solving a problem. The second part is about invisibility, right? Now, I will give you some examples of this, and again, we can go way deeper than that. But basically, it's very simple to think about invisibilities as cameras, right? But there is one area which is usually neglected, which is actually very effective, which is noise, ambient, and sound control. Now, if you hear someone screaming, and you can understand that scream is a scream of fear, and you can understand what is the age and the gender of the person who is screaming, maybe you can have a lot of information that something wrong is going on. Now, this is usually neglected, but the reality is, in our R&D, we were seeing this as a key differentiator versus having just the video. Predictive safety and law enforcement. I mean, I was touching on this very quickly before. The idea here is that you can use your digital twin when you are designing the urban environment to understand if this will increase the risk. Think about traffic accidents. Whenever you are designing a new road, the AI can tell you which are the options and can tell you what is the risk based on the data that it has about how much populated the area is and how the area will evolve as it goes, which is, again, preventing things rather than going and fixing them. And we see a lot of this. Command and control is an area which is extremely important. Now, the idea here is that everything that you see here needs to be centrally coordinated. So you want all the data, video streams, noise, information to be all getting into one single command and control center. This will work also as the basis for the data for your digital twin, because it's getting all the data about everything which is happening at the urban level. Now, the way you do that, again, with the ecosystem, is when you have a new development, you want to design an architecture which is open enough to basically make sure that every single building is providing you the same exact interface. Now, what is inside the building, for example, the brand of the sensors, can be whatever you want. But what you want is that interface to be stable, and the kind of data to be always in the same format to make sure that you are dealing with this data in an automated way, which makes sense. Now, there is on top of this noise detection technologies that we can discuss about, right? Because no matter how good you are at this, you will still have some noise. But again, the point is about interfaces, right? You don't want to limit people from what they want to achieve from the building, but you want to get the right data from the building. And the last part is about privacy, right? I touched on that before. There is, of course, we can talk about this for a full session, but just to give you an idea, we talked about dealing with video streams, right? Now, video streams will need to be seen by operators. Now there is a full set of technologies which only do one thing, which is blanking faces to make sure that the people in the video are not visible. Now, there is a possibility for you to see the people in the video, but this will be just for few operators, and they need to file, to basically request for the rights to basically to see these people, and decide that this is, of course, auditable and recorded, and it's based on the presumption of crime, so that the only moment in which you can understand that this is me talking in the stage is the moment in which you believe I was killing someone or I was stealing something, which is making my life absolutely monitored, but without the possibility of knowing that it's me, which is, of course, saving both sides of the world. Okay, I'm a little bit worried that I'm going.
Yeah, I was just saying I'm already getting the signs and everything.
Cool.
So
let me just stop on one single
correct.
thought.
If you round up and then we give
Cool.
it to the floor and then we're fine.
Cool. So basically, the last part of the story, and I will leave you with this slide, right? This is about what is happening in the world. Now, with everything becoming digital, cognitive, and becoming linked to the physical world, there is a convergence which is happening. Now, this is the convergence between the public safety in the physical world and what is around cybersecurity in the logical world. Now, with us, think about robots, think about, automated, whatever you can think at scale, which is about, drones, robots, and the like, which are enforcing law. Now, these things are great. You're saving officers, you're monitoring more, you're doing that more cost effectively, but they may introduce threats. So one big part of the story is how do you protect yourself for the malfunctioning, all the attack of this kind of robots, autonomous machine, and the like. And this is this kind of convergence. Thank you very much.
Fantastic. Thank you, Simona. And thank you to you all. Please, a big hand of applause, please, for our panelists. Thank you. And as I promised, now I bring it down to the floor. We've got our mic going around. Please raise your hand when you have questions. Unfortunately, I have to go over here now a little bit more. Please state your name clearly, what your question is, and who it's addressed to, yeah? So please, let's go ahead. In front here, we have one. Here to the left, the lady, please.
Hello, my name is Sarah. First of all, I would like to thank you all for your time. So my question is for Alicio. You touched base on two topics. The first is the importance of the human factor, and the second is that AI being a fundamental building block for Oxagon. So my question is, how will you ensure that the human factor, as you mentioned, is successfully embedded through AI? Is it through purely analytics, or does emotional intelligence need to be considered as well?
Thank you for the question. I think when we are looking at building the capabilities, right, create a roadmap. Okay. A lot of times as technologists, we tend to put technology first and then adapt it to create something new, right? We wanted to challenge that, or anyway to to come back on our steps and say, let's think about what kind of experience you want to have in this specific place. So let's take a school. Okay, let's take an hospital. Okay, let's take the residentials, right? So where we are going to live. Okay, and let's ask ourselves throughout our day how we are going to live that. Okay. And so we start with that. We go with kind of use somehow a little bit the design thinking principles in this, right? So, and then we ask ourselves, okay, we want to have, for example, autonomous deliveries, and you want to order stuff and receive it without being home, without have to that burden. Okay, how do we make it? Okay. And from there, we then derive, if we want to do that specific user experience with human in mind, then which data do we need? Which sensor do we need? Which infrastructure do we need? Which applications do we need, right? And, if you do that, then you find yourself creating the technology, shaping the technology with the human in the center, right? And at the same time, then you look at what is the best cost optimized option, okay, to then make that product and that experience available Maybe it's something that is completely new and you need to design entirely from scratch. Or maybe there is already a product out there, a sensor, an application, or something that you can then incorporate, right? And you are half the way through. So we then make the trade-offs of buying versus making and understanding which is the right things to do. I hope I answered.
Thank you, Alessio. All right, the gentleman in the middle, please.
Hi, my name is Jasmine Nahas, assistant professor at University of Tabuk. Thank you so much for the great presentation. My major concern actually for what type of historical data. You know, Dubai now is a developing country and the population maybe before 5 years ago, it may be, let's say, 5,000 people. So after let's say 10 years, it's going to be like 3 million people. So what kind of data do you guys doing benchmarking, and how you can compare the crime rate before 5 years and after 5 years? What type of the historical data in your predictive model? Thank you.
I'll take if you don't mind. So I love your questions, first of all, because you know, when you're thinking about, oh, we are creating cognitive city, we are creating AI, your high start from data, right? No, and then machine learning, and then you know all the features that comes through. But if you are a new city, how do you ensure that you are building up those data, right? Or where are you starting from? Because those data is not yet available, right? Okay. So it's one of the biggest challenge that we discussed since the beginning, since day one. How do we make it? How do we make ML without the data, right? And there are two answers to this. First of all, we use open source data, okay, around the world. Now, a lot of I use an example of you know, creating the brains that does the logistic for NEOM, so or you know, the ability to have build AI on a marketplace, okay, for selling things. Okay. Now, similar behaviors that we have in the regions, they may find okay, the same behaviors in other parts of the world. So, leveraging open source data and taking this data from everywhere, we are starting to build this initial component of AI to then enable that capabilities. And the second element is to start small and scale fast. So we creating small POCs that then leverage the open data, then enhances with the people that are already living there, our communities. We have 1,000 people now already living in our organizations, and you know, in the next few months, we will already have, for example, a marketplace in which we created AI leveraging open source data, but then that serves our community, and then learn from the community that we have already in place and get better, right? Okay, and get better and improve through times. So it's a mixed combinations of these different two elements that get us better and that get us on the long run.
So unfortunately, we ran out of time. It is what it is. I'm very sorry for that. I would like to thank our panelists. Thank you very, very much for a very insightful task force. All of you on the floor, thank you for your participation. Make sure to grab us if you can afterwards, if you still have good questions, and have a great and successful AI Summit. Thank you.
Thank you very much.
Thank you.
AI Summit, and today we're going to talk about the role of AI. So our discussion will be in English. So welcome everyone.
Welcome everyone. Good afternoon to the Global AI Summit and this session on the role of AI in Industry 4.0. 300 years ago, factories used water and steam engines, if we can call them factories, to produce products like textiles and clothing that were previously made by people, like without automation or manufacturing capabilities. 100 years after that, combustion engines were invented, production lines were expanded, more products were produced like steel and casted iron. The second industrial revolution that happened in the mid-1800s produced airplanes and cars and railroads to us. Also, 100 years after that, computers came into the picture. So in the mid of the 1900s, computers came into the production lines of manufacturing. What that produced is machines had data to look at. Machines had automation on themselves. 50 years after that, today we're talking about Industry 4.0. And the main difference that we're considering and looking at today is that those machines that 50 years ago that had computerized versions of some of them now are talking to each other. Machines are issuing tasks to each other. Machines are collecting data to a centralized hub. There are more technologies that collect data today. There are more technologies to analyze and provide insights for these data. Industry 4.0 is at the heart of the National Program for Industrial Development and Logistics Sector. It's a program aimed to achieve the objectives of Vision 2030 when it comes to industrial sector automation and logistics sector as well. In today's session, we have Mr. Talal Al-Bakr. Talal is the Chief Executive Officer of the Saudi Cloud Computing Company, a JV established in Saudi to operate Alibaba Cloud. Hayak Allah Abu Haifa. We also have Dr. Mohammed Shahrani. Dr. Mohammed Shahrani is the Chief AI Officer at the Saudi Company for AI. Hayak Allah, Dr. We also have Muhandis Saud Al-Shrehi, the Vice President for Products and Solutions at STC, the largest ICT and telco player in the region. حياكم الله جميعا. Dr. Mohammed, I'll start with you, given that Sky, the Saudi company for AI, is an enabling arm owned by PIF. What is the mandate of the company and how does it look like at AI sector?
Thank you for allowing me to be part of this panel. I will do again another introduction of Sky. Maybe forgive me for those who attended Smart City session this morning. I have to repeat it again. Well, Sky is the Saudi company for AI. It's PIF owned company. However, it's endorsed by Sedaya. So the mandate of Sky, mainly two things. First of all, it's an AI ecosystem enabler for SMEs in the market and also international players, hyperscalers who would like to enter the market, also with our sister companies as well, government or semi-government companies. Secondly, it's AI national champion in somehow. Sky core business, actually, core technologies are 5 things: computer vision, machine learning, NLP, which natural language processing, IoT, and robotics. We build our capability actually through partnership. So we are forming partnership with international hyperscaler or local players on the market to build capability for this industry. So we work actually vertically in different domains. Actually, we already in healthcare, in governments, in some application of securities, environments, and education, automobile as well. However, also cross sectors is a smart city, as you know, as it's crossing all sectors. Based on that, we are building our capability through partnerships. So we already formed a joint venture with the SenseTime MIA in computer vision, which was announced yesterday, around 800 million Saudi riyal for this GV. And maybe last month you hear the announcement between Sky, STC, together as a one team with Data Robot as well last month. And you might see today the beautiful IoT Square, which is Saudi, was in the beginning of this initial idea. And I think IoT Square, it will be the biggest player in the Middle East, if I can say so, in IoT industry. And thanks to the sister companies who's working and integrating together to bring the best of those companies and organizations for the best of our nation and country. So this is generally about Sky and somehow. We already had collaboration with STC, in Alibaba. We have small stake, but we believe it's a big opportunity to be part of this joint venture led by Talal Al-Bakr. He's well known, as you know him. And also with IoT Square, we believe that we could have huge initial collaboration. And still partnership list is ongoing. We are 1 year old. Yes, we are a startup company, startup mode, but we were born as a big company, and we hope to see something in the soon future to fulfill the demand of our market and our nation.
Well, thank you, Doctor. That's an impressive and challenging mandate. Talal, how does a cloud company help in AI activation? But before that, give us a brief on the mandate of SCCC.
Wonderful. Thank you, everybody. What we're really trying to do right now in SCCC is we saw the need for a hyperscaler, multi-cloud player to be in the region, and in Saudi specifically, due to data sovereignty requirements, due to security aspects, due to resiliency and availability of information. We needed to really sort of build that framework into Saudi. And STC and its partners saw the need to really bring those kind of technologies into Saudi. We tried to develop it ourselves. We had a little success, but we knew we had limitations. So we came with the realization that we really needed to leverage an international big player, hyperscaler, that was able to really bridge the gap. And our mandate is really to localize that information, bring it into Saudi, and launch multiple regions from that. And we're happy to say that we launched 3 months ago, and we already have the largest cloud in Saudi, and we have the first region of many that we're planning to launch, and it's based on 2 availability zones.
MashaAllah. Well, congratulations on the launch. Tell me more about industrial service specificity. How does cloud offering fit that sector?
Yeah, that's an interesting approach. Now, what we're seeing today is a lot of requirements require a lot of different data injection points. So as we start to go into Industry 4.0, we're going to see a lot more sensors, a lot more machinery, a lot more aspects that are feeding information into a huge database of equipment, and a huge database that needs to analyze it and process it. And today, the cloud and the setup of the cloud and the agility of the cloud and the scalability concept, nothing in the industry today can keep up with those kind of requirements, specifically when you have spikes in demand, bursts in requirements, and things like that. So cloud will be able to inject huge amounts of data at extremely seamless instances. And then when we start to inject it, we have our analytical engines that we can allow any entity to go in to do processing on those engines and control those aspects, and then ultimately push it into our AI algorithms and AI engines. So we have a full plethora of different solutions that allow you to control the injection rates, analyze the injection of the data, do the AI algorithms and analytical requirements and the AI deep learning requirements, and then ultimately provide you an output or a visual aspect to it.
Fantastic. Mohandas Saud, when we look at STC, and building on what was just said by Talal, STC offers a variety of service. It looks at different verticals and sectors. How does digital enablement help in digitizing the industrial sector?
That's a great question. Well, Saad and the rest of audience here, STC is a tech player we are a technology company with a mission to accelerate and enable lots of businesses. So what's happening here is that we are leveraging the capabilities that we have within the company to be able to enrich and flourish other businesses, not only businesses within STC. So as part of this, what do we do? Initially, we are a telecom company and we have a great infrastructure. I mean, the final thing where we have the latest and the biggest and best 5G network. We have the cloud services that we are going through with the Alibaba. We secure it through a cyber security framework that we do through Sirar, which is our cyber security arm, as well as the mass communication and the number of connections that we have through IoT Squared, where we can, I would say, spread sensors everywhere and making sure that we capture this value and what we get from those sensors. And this did not come overnight, or it didn't come by itself. This was based on a calculated vision and I would say even a strategy that we put within the organization called DARE. And as part of our DARE strategy, we are expanding in scale and scope. So you've seen in the, I would say within this year, lots of announcements. MENA Hub as an example, IoT Squared was the latest one in terms of companies that STC owns and as part of STC portfolio, as well as we are expanding in scope by great partnerships, like the ones that we are signing with, I would say, the leader of AI in the region, which is Sky, to make sure that how can we commercialize, how we can make sure that we are on top of our game. Technology is changing. It's evolving very, very fast. And they are, I would say, the boundaries between technologies are blurring. There's no more, you cannot claim that this is because of X or this is because of Y. It's about a use case that you are providing. And we are collaborating, I would say, even at least within this setup here, in addition to great partners even beyond this area that are really collaborating to make sure that we have a proper use case with a proper business impact to our clients.
Thank you. But before we get into commercialization and offering of these services through STC or SCCC, and I want to go back to you, Dr. Mohammed. Dr. Mohammed, when I looked at your role, you're the Chief Artificial Intelligence Officer. I personally haven't seen this before. Is this something new? Is this something that you came up with at Sky? Or is this what is the mandate, I guess, of a CAIO?
Okay, as this question maybe is part of the panel, but as you can, the mandate of Chief AI Officer, actually, it's a new box for Sky. And the mandate was mainly rely on AI trends, AI ethics, AI standardization, and AI governance, and also AI strategy for product and technology, overseeing this part in Sky. So maybe you see the importance. There are so many releases happening regarding this field for ethics. So as you might know that there was a release of UNESCO recommendations on AI principles. And then before that, there was the first edition of G20, OECD AI principles. Before that, there was also other documents from IEEE called P2839, and then ISO also. They released another document called ISO 373, it's called 37122 as well. So those releases, as you can see, there some of them international regulations, principles, some of them national level legislation and regulation or frameworks. Plus over that, I can quote what UNESCO yesterday was speaking, that the drawbacks here is how to do the alignments between the international principles, regulations regarding AI, the national level, and also the industry or the institutional governance of this industry. So this is one of the challenges facing the new companies in AI, and that was one of the challenges facing Sky as a new stakeholder in this industry. So in the pipeline, there are so many technical due diligence, AI business due diligence coming in. Also, that was part of the new role was created by Sky in the market.
All right, well, thanks. Maybe we'll circle back on this question at the end as we close. I want to go back to you, Saud. Saud, you talked about digital enablement and how does it affect the industrial sector. But how does AI specifically play a role into that? So you have your sensors, you have your technologies embedded in the factory, for example. The data will be hosted on a cloud. Where does AI benefit the customer?
Yeah, well, as you mentioned, Saad, I mean, now you have your factory, you have all your sensors, you have everything is ready. Now you are able to collect data. You have lots of information, you have knowledge about what's happening there. And AI is used in multiple fronts. I would say at most is to enhance efficiencies. And efficiency enhancements can be to generate more revenues, which means that you can do more with less, as an example, or reduction of costs. Maybe you have costs here and there and you can optimize your cost by doing it more efficiently. Second part is that you can do that by, I would say, increasing the quality. You've seen lots of use cases around taking, for example, snapshots or pictures of vegetables, fruits, or even any packaging that you have to make sure that they are within the quality standards that this company is standing for. So quality is also an important factor when it comes to AI, and it's a big supporter in that domain. And third, but not the last one is around how can you, within AI, I would say increase the safety. Maybe this is overlooked sometimes, but increasing the safety and security of the citizens and whoever is available there within the factory floor is very important and crucial. And this is, of course, it can hit also other elements like reduction of power and the sustainability part, and how can you make sure that this business is more sustainable, which is around the people and the resources and whatever you have within the floor. So all those aspects, and I'm gonna come from, again, a tech background or a technology company, putting all this together is what AI is all about. And how can I put it, it's like AI is the brain behind this. You can use the sensors like your fingertips here, and you have the nerve system that collects this data and put it into the memory where you have it, and then where it's processed and getting to learn a lot in the cloud, and where you can learn more and more as you move forward.
Tamam. Talal, as a customer, as a potential customer, so industrial sector, industrial cities, factories, production lines, even many production lines now as SMEs are getting into the business. How can they look at cloud-based AI offering? How can they evaluate? Are they looking to look at different business models, if any? Can you talk us more about that?
Yeah, that's an interesting question, actually. What we're seeing today is the need and the proliferation of open source technologies. Now, what's very critical about any cloud provider is that they provide the opportunity to migrate and the potential for no lock-in. So today, if I provide a cloud solution that I'm locking you in, that is an actual risk. And we try to build our solutions in a governance model where we provide the opportunity for you to move to any cloud if you so want to. But we believe that our superior service, our superior pricing mechanism, and our superior customer intimacy will maintain the relationship and keep you on our cloud. So the aspect here is about really opening things up, leveraging the enhanced capability and development of the open source community, which today, if you look at it, all AI development is happening today. Almost 90% of it is based from the open source community. If this trend continues, then we have so much potential to tap into that a closed ecosystem will not be able to leverage. And we're really focusing on that. So that's one of the aspects that we're really very interested about. Another aspect is, as we start to bring in new technologies and new open source aspects, there will be an evolution to some specific closed source technologies. How do we ensure those closed source technologies also don't lock in customers, allow you the full benefit of tapping into the different open source technologies, and allows you also the capability to migrate from one ecosystem to another? Ideally, what we're trying to do is we're trying to improve the performance, improve the feasibility, and improve the usable install base and customer base. The more open we become, the more we're going to be able to have different people with different outlooks innovate on our platform and come up with new and innovative solutions. And that, for us, is a professional mandate that we believe is needed, and it's also a national mandate that we're very interested in helping and supporting on.
Great. So we talked about, if we look at it as a bottom-up stack, we talked about the half-bottom with what the Alibaba JV can bring to the table, and maybe the product and tailored use cases from STC's point of view. Dr. Mohammed, when we talk about Sky in Industry 4.0 specifically, what is the vision basically for Sky in enabling this vertical specifically?
Well, there is a misconception actually, it's common actually in this industry. Many people think that, or even individuals, even some of them work in this industry, they think that 4.0 mostly is focusing on industrial automation. But what Saud mentioned is more beyond the industrial automation is just part of smart factory. So we are talking about what Saud mentioned, quality, predictive quality in terms of predictive maintenance, but also there is a human-robot collaboration, even a new concept with his generative design. Even AI can help this industry in the designing phase, during the designing the scenarios, to optimize the scenarios of designing in this phase as well. So plus the market adaptation and also supply chain as well, out of the factories as well, it will enhance the supply chain and logistics. As I mentioned, that one of the core technologies of Sky to focus on, to rely on, is robotics as well. And from this part, we came to collaboration with STC, with IoT Square, from IoT's perspective, and also with Ali. Maybe Mohandas Dalal didn't mention that Ali, they have very strong capability. It's called the industrial brain, which is one of the most potential product they can bring to the market, already mature. I see it in China. In the last 5 years was stable. It was already also used by China, one of the biggest logistic shipping carriers done by Alibaba Group ecosystem, and it's very mature and stable as well. So we believe there is potential collaboration between Sky and Ali Industrial Brain, or even with the infrastructure and platform. Actually, they have huge products here at application level and platform level and infrastructure as well. But also we already form a partnership with STC with DataRobot as well. DataRobot, they have one product regarding industrial optimization. They've done some of the products counting ROI investments, on the industry as well. It was very successful use case in the United States. So we are expecting to jump to this field in the soon future. But we take with us, our mandate is as AI ecosystem enabler. So we are trying to collaborate with local SMEs, trying to have the end application and the last miles always to be implemented by the local SMEs as much as possible, and Sky to be the enabler in the backbone of the application or the system with our sister company or our partner.
Fantastic and very promising. Abu al-Bandri, Saud, we talked even with Talal, mentioned the use cases and digitization of factory ground floors or factories in general from technology offering point of view. But for the chief executive for that enterprise, if we want to talk about business value and operational efficiencies, for example, what are we bringing to the table introducing AI in Industry 4.0?
Well, I would say this question is exactly the bottom line of how I would say organizations are looking at this. Maybe, I'm just saying maybe, majority of the people here are tech savvy or coming from technology background, so we like technology. However, when it comes to organizations, we care about the bottom line. We want to know what kind of impact. I could care less whether it's a 5G or 4G or cloud or security, it doesn't matter. It matters that what kind of business outcome that I can generate and I can bring. The good thing is that this, I would say, in AI proved its value in terms of return. I'll just give a few examples. When it comes to predictive maintenance, you can just collect the data that you have from multiple sources in different areas, and you can reduce the time or the outage time by around 40% or more. Actually, there was one of the studies that they added a small sensor, which is a vibration sensor, on top of the machine. So they did not even interfere with the machine. They just put a vibration sensor, and if this machine vibrates like funny, it would immediately tell. And this reduced the, I would say, unplanned downtime by 25%. This is actual bottom line and revenue impacting kind of, I would say, activities to the end user. Another example, maybe stepping out of the, I would say, the industrial floor, as Dr. Muhammad mentioned, in healthcare, AI is helping doctors when it comes to, for example, tele-ICU. Instead of, based on the standard today, the maximum number of patients that an ICU doctor can see is around 12, if I'm not mistaken. And they cannot see anyone more than that because they cannot focus. They have to go around for each patient and read their vital signs and to make sure that they take proper decisions. But now with the help of AI, there are solutions today that one doctor can serve 150 patients. So it's more than 10 times, I would say, the efficiency and the output that each doctor is producing. When this becomes more critical and more important, it becomes more important when the resources are already scarce. There are not enough ICU doctors today. So it's like hitting two birds with one stone. So we are hitting both objectives within the same solution. And I could speak for hours around robotics, as Dr. Muhammad mentioned, and the things that, and how can robotics help when it comes to either from logistics or even for within the, I would say, the shop floor, to be able to have the future of the industrial revolution.
طيب. I want to take the same question and direct it to you, Talal. Do you have more to add to that from a business value add?
Well, I would like to thank the doctor first off for reminding me about industry brain. Yes, I'll remove it from the next order as a commission. So thank you very much. Actually, what Abul Bandari was mentioning was extremely accurate. As we start to progress and evolve and learn more about AI, what we have to remember, AI is still actually in its early stages. So there is a huge journey ahead of us. And till today, we've seen a lot of benefits and we've tapped into a lot of potential. And we continue to really unlock its capability. What we're going to be able to do as we start to progress, as we start to get more data and be able to analyze more data, come up with new engines that will allow us to do deep learning and machine learning, we're going to come up with new use cases that we never even thought about. And again, AI is an enabler. And it's going to help us a lot, but the human element is always going to be there, the human component for use cases, for analyzing use cases, for coming up with innovative ideas. Like if we touch on the point that Abul Bandari touched upon, which is a simple sensor. That's a human innovative idea. It didn't really complicate. If you would probably address it to an AI, you'd get a full digital twin before you came into the aspect for that. The human element to streamline and simplify those aspects is going to continue to be there. And as we start to progress, as our algorithms start to become more fine-tuned, as we start to understand how to teach machines in new and innovative ways, we're going to be able to tap into potential and tap into the industry and really evolve it in a very good way. When we look at also what we're doing specifically in Alibaba on the industrial aspect, and if I touch on the different brain aspects, today what we're doing with regards to industry brain is we've built a platform that allows you to tap into the different elements of an ecosystem requirement. So today you have the data injection aspects, you have the predefined algorithms and predefined machine learning modules that you can really tap into, and you can start to leverage that and build the visualization layer or the output layer that you need to have, be it on an API basis, be it on a visual basis, be it on a machine-to-machine communication basis, and sort of control that element. And it's an exciting time to be in this industry. we are going to continue to evolve. I'm sure that in this event, 5 years from now, we're going to talk about things that will make what we've talked about today make no sense and be obsolete. And that's the exciting thing about it. And I'm very happy to be part of this community and be part of a company that's part of this amazing ecosystem that is going to take this to the next level.
طيب, thank you. Saud, building on what Talal just said, it is still early, but it also has been around for a while, AI. So STC has invested, as you mentioned earlier, in AI in terms of hardware and partnerships, the best of the breeds internationally. Can you tell us a couple of success stories that we did in the market, in the Saudi market, in the industrial sector specifically?
Sure. Well, there are lots of success stories that we've done, and as you mentioned, Saad, is that we built the infrastructure, we built the platforms, just to make sure that it's not for STC to do it, for STC to do all those use cases. That's why we are having this partnership. So Alibaba is doing lots of GPU stuff, so anyone who wants to train machines, it's already available, and we can accelerate this on top of different platforms and great use cases that Sky is building as we speak. So as part of also our vision, we started making sure that we make major steps into success use cases and what can we do. So there are two things or a couple of points that comes to mind. The first one is related to the agreement that we just signed with Moana. Moana is, we want to, I would say, basically digitize the seaports that are available within the country. So basically what we are doing, we are equipping them with the latest 5G technology, cameras, and making sure that there is a huge intelligence to be able to measure, to be able to control those cranes. It's not easy job for them, and efficiency goes a very long way. And the good thing about this is that it hits immediately to a country target as well, because we want to process many and we want to be a logistical hub. I'll just give you one small example of what is happening there. The containers, if any of you have seen them before, they come in different languages. They can come even in Chinese sometimes. So how can an operator check it, read it, translate it, and make sure that those, I would say, the right reporting is taking place in the correct manner? It's not an easy job. How can we make sure that the technology is there to be able to capture it, translate it, and capture everything? So this is one of the great examples that we did. Second part is a use case that we did for you can say a healthcare sector, but it can be easily deployed in the industrial sector, which is when COVID hit, immediately government entities came to us and say, we want to identify who's wearing masks, face masks. So we equipped cameras with 5G and we put a great intelligence in the back end and made sure that a camera can sense and tell a command and control center, because you cannot have enough guards everywhere just to monitor who's wearing mask and who doesn't. It will tell you what's the percentage of people wearing masks so you can take an action or not. And this could be used easily in the industrial space by making sure that they follow their safety standards, like wearing helmets, wearing the safety shoes, etc. So those are just a couple of use cases that we've been doing, and we've been doing them successfully.
Okay, so from that I'm distilling whatever we do in an industrial sector, per se, for this example, we can transfer that knowledge into other verticals, healthcare, education, smart city,
Absolutely.
as we develop these capabilities. So I know that STC has a wide variety of verticals it's focused on, but I want to bring it back to you, Talal. Today, the core of it is the hyperscaler. Everything will sit on top of it. How do you approach other verticals, given what you just said about the capabilities within the industrial sector?
Yeah, it's actually a very important aspect. Now, one aspect is Alibaba has established that each vertical has a different approach and different unique requirements. So if you look at our intelligence platform. So we have the brains. So we have city brain for smart cities. We have industrial brain for industry 4.0 factories and so on. We have the health brain for the health sector. And we have, I think, also the financial brain that for fintechs and financial institutes. So verticalizing it was based on the aspect of each individual industry approaches data, approaches AI, approaches the way it wants to come up with outputs in a different way. So, and each of them has its own modules that you need to really tap into and start to build machine learning and deep learning algorithms and platforms to address. And as we start to progress, what we're seeing is initially a lot of modules can be utilized anywhere within the AI platform. And as we progress, we're seeing a lot of more specialization. So some things that would have been applicable in any industry right now only applies for one. You need to develop and come up with your subject and work with your subject matter experts and come up with industrialized use cases that are extremely specific to a niche. And as we progress, we're going to see that niche grow smaller and smaller. So today, we're talking about industry brain. Tomorrow, we're going to see probably factory brain, and we're going to see logistical brain and things like that, and sort of breaking it down into even smaller, minute aspects, and leveraging the similarities between those niche industries further and further. So we're going to see that evolve. We're going to see that all tap into the different elements of the cloud, and we're going to see different sort of offerings and ecosystems that are going to evolve in those different industries.
So we're talking about a lot of brains. We're techie people, and so this excites us all. But there are a lot of people that have concerns about where AI is going and the decision making that it's going to have and the ethical boundaries that Dr. Mohammed touched on in the beginning. As we get into the next decade and how AI transformation will take us, Dr. Mohammed, you mentioned about the ethical and the standards that are issued by UNESCO or other organizations. How do we control this beast? And I don't know if control is the right word, but how do we set it on the right path as we go forward in terms of ethical consideration, decision-making consideration? And is this part of what Sky is looking at in the next phase of its focus?
Okay, maybe I mentioned already the international regulations, and I mentioned them by name, but yesterday, maybe by end of, I think the last session yesterday, Dr. Majid Tuwaijri, the chief of Saudi National AI Strategy, announced KSA AI ethics. So the KSA AI ethics rely on anchored 7 principles, started with fairness, privacy and security, social impact, social and environmental benefits, also safety, reliability. So those 7 principles, it's showed clearly, and also they also not just a principle, but they move from principle to practice, which is one of the most challenges today in trustworthy AI, is how to move from principle to practices. And there are many challenges down the line. So they set up 4-batch system, bronze, silver, golden, and platinum. So to classify each company based on their trustworthy AI and ethics. So trustworthy AI, trust in data, trust in model, and trust in process as well. So it's a new in the world. Saudi, one of the countries who adopted AI ethics in very early stage. So how to approach trustworthy AI? Well, it started actually from the education. Today we teach our engineer how to build a product, how to program, how to design a product, but there is not enough material. It's how to build it ethical by design. It's common today as a concept secured by design. So why it's not ethical by design? So it will take a long way actually from education, universities, private sectors, all the stakeholders actually. And the complex here is that the AI stakeholders are growing. So it will start with the engineer. When you deploy the engine or the model in the organization, it's not done. Actually, you will scale it up. There are integration with other players, and the stakeholders will growing and growing regarding this matter, even to reach the top leadership and the governments, entities and leaders. So to have trustworthy AI journey, it will be long journey, but Saudi already acted. If you are working in Europe, then you must be aware there is AI Act. And if you are an investor of VC, you should be careful because AI Act will impact the market. We're mostly in positive way, but you have to how to walk around it and to find ethical ways and not impacting also your business and growth and also your company revenue as well. So if you are in the US, there is something called Algorithmic Accountability Act as well. So there is something called also ethical design act as well. G20, the first edition, and OECD AI principle as well. So as a stakeholder, you should be aware actually, especially governments, top leadership in the government, especially the CX suite level of the organization, whether you are a consumer of AI product within your organization or if you are a productive company to sell products or you are part of this ecosystem. So finally, where is trustworthy AI within 4.0 industry? Well, there is ISO already released several mature level 9, I think, already releases in terms of 4.0. But where is part of the trustworthy AI? It's not completed yet. There is ISO, they release 32177. So 37122, 2019 in May, but it's still in early stage as well. So there is standards, different organizations work on 4.0, but however, from ethical side, still need the long work to work with collaboration with the national level standard organization. So this is generally where trustworthy AI could impact the 4.0 later on.
Could I just ask a question here? Because I think it's something very important. Now, today we're at Saudi's adoption of AI is at early stages, and yet we've come up with a lot of guidelines and principles and ethical requirements, which is extremely important. But the reality of the situation, we are aware that there are countries that have been using AI and have developed AI for multiple years without oversight, without any control, without any acts to really guide them and control that aspect. Do you think that would be a hindrance for us to catch up with them? Or are there controls in place to limit that and to really allow us to execute?
Well, it's a debatable, big debate question actually. It's a $1 million actually question. So it's actually to catch up, well, Saudi already has tremendous work. And if you believe in your citizen and your people and local talents, you can achieve many, many things you never expected. When Sedaya, actually how old is Sedaya? 3 years, and what they have done when COVID break out, like this, everyone just activated Tawakkalna. And today we are in the parallel with data, also with AI. Yes, I'm in China for 10 years already, and I've seen many startups, whether in Beijing or Shenzhen, in Guangzhou, or in Shanghai, business field, also close to Hong Kong as well. So there is some acts. Cybersecurity law was introduced in 2017. in China, and big data, actually, they call it Tasu Fancy law. They introduced, it was popular in 2016 as well. I understand what you mean, but at the end, it will rely on the data, the access to the data. Those nations who came lately or recently to this industry, the duty of the governments to help those SMEs to have an access and enrich their models by large-scale data sets. I believe the access for those SMEs and startups, even large corporations, when they get the access from governments, open data access and other data not available for large corporate, only they can get it from their massive large application. I believe we could do something, in very short period of time with more accurate, as your data is localized, your data, you have the access and you can catch up. And I have one story we've seen in Sky and inside the National Center of AI of Sedaya. We work with, for diabetes eyes, with King Khalid Hospital, and also with Lean Healthcare. Together we form 4 companies, and this is collaboration, how it comes from. So Lean, they take care of the healthcare side, Sky take care of the AI. The Sedaya, the R&D center, most of them young Saudi beautiful boys and girls, they've done this engine, and the lighthouse customer was King Khalid Hospital for Eyes. And today you are welcome to go to the booth, and you will test your eyes. And there is 2 physicians, if physician right word to use. I'm not that good in healthcare, and you can see if there is, and I hope you will not be suspected for diabetes eyes. So this is maybe somehow diplomatic answer of your question.
I think we have more questions on AI next, or AI never, I'd say, but we don't have answers to. I'm not talking about this panel, I'm talking about the community overall. But as His Excellency Dr. Engineer Abdullah Suwahi yesterday in his opening remarks said, we will never know where AI is going specifically, but we know one thing for sure. If you use AI, you're going to be better off than the other person who doesn't. And with that remark, I want to close this session. I want to thank my panelists. I want to thank you all for availing your time, and enjoy the rest of the day.